So, welcome to Zaragoza, virtually or physically. I think we have seen yesterday evening during the city tour that it's a town with a lot of history and a very nice venue for this meeting. But obviously what brings us together is not old history, but it's obviously other things man have done over time, trying to improve our lives, to advance technology, but sometimes then obviously forgetting that a lot of things comes with a price, including obviously using pesticides. In the beginning, it looked like a very good thing, but over time we also understood that using pesticides has also another side of the medal. And so this session is to explore, on one hand side, what means the massive use of pesticides for the Central Asia region. For those who are not very familiar, this has been in Soviet time one of the central areas for cotton production, with very massive use of pesticides. As one of my Uzbek contacts one told me, cotton from a seed until it was harvested, so 90 different agrochemicals. So you can imagine what this means for the soil on which the cotton was growing and for the people who were working in the cotton fields. We will have, I think, first a layout on how agriculture could look in the coming future, given by Mark Davis, whom you see besides me and who is the co-chair of this meeting. Then hopefully we will be able to have a roundtable discussion with our Central Asian participants to better understand what are the obstacles to deal both with the obsolete pesticides legacy, but also to introduce better agricultural practices which rely on less and less dangerous pesticides. And then we would like to present you the GEF project, which FAO is currently implementing in Central Asia, and to tell you on progress we have done in various areas, both on addressing obsolete volumes, but also in introducing improved agricultural practices relying on less pesticides. So this said, I would like to hand over to Tania Santivanez to give a welcome and a short introduction from FAO side.
Thank you, Stefan. I will speak in Spanish. Thank you in consideration that now we have translation.
Dear participants, colleagues, friends, I welcome you to this meeting. On behalf of the Regional Office of FAO for Spain and Central Asia, I'm pleased to welcome you to this session on life cycle management of pesticides and disposal in Central Asia. Please allow me to say that FAO promotes a close collaboration with governments, the academia, private industry, the NGOs, communities, and farmers, because this is critical to ensure food security and transition towards more resilient food systems. This is why it's important for us to be part of this forum and have all of you here in these sessions, since we need to intensify our efforts to find joint activities to generate solutions to the challenges linked to pesticides, and in particular obsolete pesticides. As you know, David has already said it, unfortunately, due to a lack of proper management and planning, the contamination and use of pesticides during the Soviet period or Central Asia countries suffer the consequences of this. A huge amount of obsolete pesticides exist in the region, and there's still a serious danger both for the environment and human health. Through this project that we've been implementing for several years, we've done a lot to find a sustainable solution to help these countries to tackle these issues. In particular, when it comes to the final disposal of obsolete pesticides and the prevention of the accumulation of new products. These substances, toxic substances in general, are stored in open air, in containers with leaks. There are leaks towards the ground and water. So local communities cannot develop if their soils and water are contaminated with pesticides. So their population cannot thrive if they suffer from diseases caused by pesticides. Dear colleagues will know that the process of removing and safely disposing pesticides is technically complex and highly expensive, and it requires a lot of time. That's why it's very important to prevent the use of obsolete pesticides. We need to pay particular attention to the accumulation of new obsolete substances and the disposal of these. Through the promotion and implementation of agricultural sustainable farming practices, comprehensive management of pests, reducing the use of pesticides, and ensuring a better management of these. These issues should be considered a priority to all of us. In particular, this time of multiple international crises. Now more than ever, we need to gradually reduce the use of pesticides to protect our natural resources, biodiversity, to preserve biodiversity, to produce healthy food, and to protect communities. Obviously, this will allow us to have green agro-food systems. In this sense, the aim of this session, as previously explained by Stefan, is sharing and discussing with all of you about the main challenges and opportunities and developments achieved in Central Asia so that obsolete pesticides are no longer used, and to gather all of the stakeholders, all of you, to find strategies, mechanisms to solve the issue of obsolete pesticides in Central Asia and to improve the management of pesticides. Thank you for your attention. I hope we're going to have a really fruitful discussion.
Over to you, Stefan.
Thank you very much. I forgot to mention Tania. She's a lead technical officer at FAO. She's based in Budapest, and with regard to this project, she's the overall responsible for this project. And I'm very happy that she was able, or she is able, to cut out the time to attend our session, at least virtually, out from her busy schedule. Now, the next speaker I want to introduce, who will give us a general introduction into how agriculture could evolve, is Mark Davis. Mark Davis has been also working for many years at FAO and has been also centrally involved into developing work on obsolete pesticides management. He has retired from FAO a few years ago, and is continuing to work on issues. He has been always very concerned in his work with FAO, and what these issues are, I give Mark himself to present it.
So we're talking a lot about obsolete pesticides. We're talking a lot here this week about the legacy, the historical legacy of misuse, overuse, oversupply of pesticides and the problems associated with that. The question I'm asking is, are pesticides themselves now obsolete? And I will discuss this a little bit in the following few slides. So there is current thinking amongst many international organizations that I give a few quotes here. These are just a few examples from recent speeches and presentations that have been made and documents from different organizations. From the Stockholm Resilience Center in 2022, just last year, they said the cocktail of chemical pollution that pervades the planet now threatens the stability of global ecosystems upon which humanity depends. And the UK Chief Scientific Advisor recently said that the assumption by regulators around the world that it is safe to use pesticides at industrial scales across landscapes is false. Here's an article that was published in Nature Plants just a few years ago, saying there is no conflict between low pesticide use and high productivity and high profitability in the majority of arable farms. And the UN Special Rapporteur on the right to food recently said, today's dominant agricultural model is highly problematic, not only because of damage inflicted by pesticides, but also their effects on climate change, loss of biodiversity, and inability to ensure food sovereignty. So basically, what's the message that's coming through from important thinkers and policymakers is that pesticides are probably causing more harm than good, and we need to rethink the system fundamentally. Pesticide use has been increasing substantially over recent decades. Since the 1990s, for example, until just a couple of years ago, we have seen a consistent increase from about 2.5 million tons per year to over 4 million tons of active ingredient being used annually. At the same time, we have a researcher called Erk, who published an important paper demonstrating that pesticides are not necessarily doing what farmers and producers think that they're doing. And he has said the increased use of pesticides since 1960 obviously has not resulted in a significant decrease of crop losses. You still hear organizations, including FAO, saying that crop losses annually are between 20 and 40% of production. I would dispute this figure. I don't think it's correct, and I don't think that the research has been done to demonstrate that that is correct. But the figure is very widely used, and industry uses it as well. We are losing between 20 and 40% of our crops, therefore you need to use pesticides. First of all, we are not losing between 20 and 40% of crops, because without pesticides, there are many natural controls that come into effect. Secondly, pesticides are not solving the problem because we're still losing between 20 and 40% of all our crops, if that's the case, if those figures are true. So the whole process is based on misinformation. And this increase in pesticide use is happening despite the fact that there is tighter regulation on pesticides, there is higher biological activity in the pesticides that are sold today than there was in the pesticides that were sold in 1990. So they should be more active and more effective, but they're not. There is more specificity in many of the pesticides that are being used. So many of them are better targeting the pests that they're being used against, but still more of them are being used. There is greater awareness amongst users, amongst regulators about the problems associated with pesticides, but still more of them are being used. There is higher literacy in many countries amongst farmers, but still they're using more pesticides, even though they know what the hazards are. And there are very many more alternatives available. More biopesticides, more understanding about agroecology and other controls, but still more pesticides are being used. So on the left-hand side here, you see that when you're targeting the pest organisms, it is impossible to avoid the beneficial organisms because pesticides are not selective. The way in which pesticides are applied into a field is not selective. They are broadcast into the environment. And let's remember, pesticides are a group of chemicals that are designed to be toxic to living organisms. If they're toxic on the nerve systems of an insect, they will also be toxic to the nerve systems of a reptile, a mammal, a bird, a human being, and a fish. They are equally, and in many cases, more toxic to those organisms. So when they're being sprayed into a field, they are affecting all of these organisms. So are these chemicals doing what farmers and users think that they're doing? Well, we know that they are impacting predator and prey populations, which are declining, and they are much slower to recover than the pest populations. Pest resistance and pest relocation is a fact. Pest resistance occurs because a certain proportion of the population survives the application of pesticides. They breed quickly, and they breed that resistance into the next generation, which increases over time. Pest relocation is a common practice. Those of you that live in urban environments where there are mosquitoes will know that if the neighbor is fogging or spraying against mosquitoes, they'll come into your house. So relocation is a real fact, and they'll just move away, and then when things are clear, they'll move back into the field that's just been sprayed. Some pesticides increase the nutrition and the palatability of the crops that they're sprayed on, so they actually attract more pests. Many beneficial organisms, apart from predators and parasites, are also declining, such as bees and other pollinators, wild pollinators, and other animals, including amphibians, reptiles, birds, mammals, many of which depend on the insects that are being decimated by insecticides for their food sources. So many of these populations of beneficial organisms are declining around the world, and that's being widely documented. Soil biota is depleted by the use of insecticides and fungicides and herbicides. When soil biota is depleted, the soil becomes a sterile environment which cannot sustain the production of crops. Therefore, the production of crops becomes increasingly dependent on chemical inputs, fertilizers and pesticides. And the more of those fertilizers and pesticides you apply to the natural environment, the more damage is being done. And therefore, farmers are trapped into a cycle which they cannot escape from. And some pesticides are also phytotoxic, so they're also reducing crop yields. Of course, we hear a lot about the impacts of pesticides on people. Recent research, which has supplemented what WHO was saying for many years, WHO figures from the 1990s said there are about 3 million people being poisoned annually. More recent research published just 1 or 2 years ago is now saying there are 385 million poisonings from pesticides a year, every year. There are also 15,000 deaths from accidental exposure every year. Now, the organization I work with works on pesticide suicides, which is not a widely discussed issue. 168,000 people a year commit suicide by intentionally drinking pesticides. This only happens because the pesticides that are available to these communities in developing countries are highly toxic. If those pesticides are not available, people do not die. It's a simple fact. It's not that these people will turn to another form of suicide. They will be sending a signal to their community in a moment of distress. And when that moment has passed, they are happy to be alive. So if the chemicals that they consume at that moment, which is what's available to them, are not deadly, then they will not die. And we've demonstrated this in, for example, in Sri Lanka, where a number of chemicals, maybe half a dozen chemicals, were banned. These were the ones that were identified as causing most deaths. When those chemicals were banned, with no negative impacts on agricultural productivity, they reckon that they saved around 100,000 lives, which is significant. So many countries are recognizing that there are problems with pesticides and are starting to take action. The European Union, for example, in its farm to fork strategy, aims to reduce pesticide use by 50% in the next decade. That's a major ambition, and we very much hope that they will achieve that. The Convention on Biological Diversity, which is negotiated by countries, has recently come up with a new target suggesting 2/3, 60% of pesticides can be eliminated from use by 2030, even more ambitious than the European Union. India is reviewing 27 of its pesticides at this time to consider banning them, on top of bans that have already taken place. China has already banned 22 pesticides and is considering another 10 pesticides for elimination. Mozambique withdrew 39 pesticides from its register when FAO helped it to implement a project on highly hazardous pesticides. So we can do without very many of the pesticides that are out there being used, despite the fact that companies continue to defend and sell those deadly chemicals. So the current model, I think we can agree, is fundamentally wrong. And we need to take into account the fact that when pesticides are being sprayed onto a field, 99% of them miss their target, which means that the majority of them are actually causing damage elsewhere. So what's the model that we're aiming towards? We need a much more holistic approach to crop production, which takes into account not only the needs of pest management, but pest management is a part of production, which, if it's going to be sustainable in the face of climate change, also needs to be looking at the nutrition of the plants, the irrigation of the plants. Healthier plants are more resilient to pests and diseases, and therefore you need less pest control interventions. The physical environment in which the plants are growing is important. If there's better airflow, there will be less fungal disease. If there are barriers that prevent flying insects from coming into your field, they will be better protected. You need to look at the varieties of the crops that are being selected. Are they resistant to the pests or the diseases that are prevalent in that environment? Are they the right crops to be growing in that particular climate? You need to be looking at the ecosystem in which the crops are being produced. And we need to remember that crop production is a natural process. It depends on natural systems and natural processes. And if you damage those, then crop production will be undermined. Very importantly, the soil is vital in order to ensure healthy crop production. So if we look at pest management and the options that are available to us, we first of all need to be looking at agroecology as a methodology. There are tools and weapons and defensive mechanisms in the environment already that farmers can depend on if they are aware of them and if they protect them appropriately. If we do need interventions, let's look first at cultural controls. How can we space our plants? Which varieties are we selecting? When do we plant? When do we harvest? Many cultural tools that are available to farmers in order to help prevent and control pests and diseases. There are mechanical controls such as traps and physical controls that can prevent pests from attacking the crops. There are biological controls. An increasing number of biocontrol interventions are available on the market. In fact, the biopesticide industry is growing much more rapidly than the chemical industry, and there are new solutions available every year. And finally, let's look at chemicals as a last resort to supplement, but not to damage, all of these other controls that are available. Just a few images to give examples. Ecological controls can include birds and amphibians. Cultural controls can include the spacing of plants and intercropping using crops that push, pull, repel certain pests from them, or that pull the pests into a different environment. We can look at physical barriers. Here they're using netting to prevent insects from landing on crops. Here they're using pheromone traps to trap substantial quantities of pests. Here biological controls are attacking. Here fungi are killing an insect. Here parasites are laying their eggs on an insect. And there are new technological developments. And I'd like to spend a moment just talking about the digital technology revolution, which can provide solutions. And here an article is being talked about using lasers to attack insects, which is becoming a reality, not quite there. And here I'm going to show you a video that lasts just for about a minute, if I can get it running.
farming becomes more challenging every year.
Small-scale robotics. And I've recently had a discussion with somebody who spent many years working in Silicon Valley, who believes that if we make the hardware and the software for robotics open source, then we will have innovators in Africa and in Asia and in Latin America who will take this technology and who will develop it for their own needs. So we can get young people who currently are abandoning agriculture to take up this kind of technology and develop it as a service to their farmers. A robot is cheaper than a tractor. A robot does not compress the soil and doesn't disrupt everything else in the ecosystem. It can work 24 hours a day. It can identify specifically pests, weeds, and it can control them with absolute accuracy without harming crops and without harming any other organisms. This is the way forward, and it can be done, and it is being done. At the moment, it's being done on a commercial basis, and it's expensive. But it could be done on a much better basis, which is accessible to all. Okay, here are some images of other robots that have been developed, doing other work in the fields. There are robots here that can identify the state of the soil in terms of nutrition and irrigation, that can identify weeds and control them, and can identify other pests and control them. And with that, I've used a quote from Greta Thunberg, who's influencing policy globally at the moment, and she is saying, we cannot save the world by playing by the rules, because the rules have to be changed. Everything needs to change, and it has to start today. And that applies equally to agriculture and to pest management, as well as climate change. So thank you for your attention.
So Mark gave us a grander outlook on what things went wrong and how things could be repaired. We will have now a round table with 4 representatives from Central Asia. I have the pleasure, besides me sits Javidan Guliyev. He's representing the Azerbaijan Food Safety Agency, which is responsible for the entire life cycle management of pesticides in Azerbaijan. Then a bit further away sits Tinatin Doolotkeldieva. She is working at the Turkish Manas University in Bishkek and is doing bioremediation trials for us, and she will give a separate presentation later on. And virtually, I have 2 other colleagues from Central Asia. We have Mansur Oshurbayev, who is the head of the waste department at the Ministry of Environment of Kazakhstan. Good day, Mansur. And we have Dobry din. And we have Ulughov, who is a project director at the NGO PESTICIDE in Tajikistan. PESTICIDE is working for many years on dealing with the contaminated soil and obsolete pesticides legacy in Tajikistan. So we will have now maybe 30-40 minutes of time to get our audience here in the room a bit acquainted what means Central Asia, what is the obsolete pesticides legacy, and also where are the obstacles to go in direction of what we have just seen from Mark's presentation. So I assume that most people in the audience have never been in Central Asia. So I would like, as a first question, for the speaker to very briefly introduce their country in a few sentences. What is the role of agriculture in their country and how important it is economically, but also in terms of jobs?
Good morning, good day, everybody. I am scientist from Kyrgyzstan, but I am no government body. But I am bringing with me some short information about agricultural situation. how we are using pesticides, how we are storing pesticide in which conditions. I am going to give some short information about agriculture in Kyrgyzstan. Exactly, agriculture in Kyrgyzstan is an important sector of the economy. It comprises about 20% of total GDP. Also, this sector occupies 48% of the total labor force. Also, more than 60% of population living in rural areas and depending primarily on agriculture. Today, 3/4 all arable land in Kyrgyzstan already privately owned, and the private sector produces about 90% of agricultural output. The main agricultural crops in Kyrgyzstan are tobacco, cotton, potatoes, vegetables, grapes, fruit, berries. Second largest crop is winter wheat, barley, barley, corn, rice. What is situation using pesticides in past and how is current how is this different today? As well known, pesticides are not produced in our country, but total supply of pesticides in our country has decreased significantly since 1990. This is due to only the collapse of Soviet Union. This only rupture of existing economical ties and the low financial capabilities of farming, but also the decrease in pesticide consumption rates for 1 hectare. For example, if in 1999 the consumption pesticides per hectare was about 3.7 kilogram, now it was about 1 kilogram per hectare. Today, for the needs agriculture, commercial structures import approved pesticides, but their list does not include POPs. Some unauthorized appearance in country of pesticides containing POPs is possible only when they are smuggled. Over the past 20 years, pesticides classified as persistent organic pollutants have not been imported in the country. What is size and the type of obsolete pesticides and the related wasted legacy? A big problem in Kyrgyzstan, it is related to storage conditions. We have more than, accordingly to national inventory, we have about 5,447 tons of obsolete pesticides. They are placed in burial grounds, of which 2,000 tons are POPs. Also, these places unguarded. People are using building materials of destroyed, dismantled former warehouses to construct residential buildings, mosques, rooms, puppets, also for store agricultural products. The Department of Chemicalization in the Plant Protection Department prefer risk management plans that provide treatment or long-term management of contaminated materials on site. This is because there is currently no site for long-term storage or disposal of pesticide contaminated materials in Kyrgyzstan. Also, we have no place for central storage facility for store pesticides. About priorities, there are so many materials. I don't know.
Okay.
We have some time to do everything. Yeah.
Let's maybe pass this first question. I think you already answered 2 other questions.
Yeah. Thank you very much for attention.
Javidan, a quick presentation of Azerbaijan. What is the role of agriculture for Azerbaijan?
Thank you, everyone, again. I would like to inform about Azerbaijan agricultural situation in shortly. Azerbaijan has always the main agriculture country in Soviet Union time and also now. And our today's topic is related, especially Soviet Union time agriculture period, because if we have now problem about obsolete pesticides, it's directly related with Soviet Union agriculture period. But in that years, if I can inform you about agriculture situation, I would like to give you some statistical information, especially in the 17th, 18th year. There was fundamental change in the agriculture of our republic, and attention to this field increased significantly. The main agriculture product was cotton, grape, grain, tea, and different fruit and vegetables. And in 1969-79 years, great progress was made in the agriculture of the republic. During these years, grain production increased by 2 times, cotton production by 2.5 times, grape production by approximately 4 times, and also vegetable production 2.5 times. And if I touch our problem, I would like to say that the widespread use of pesticides in the Soviet Union period lead to the excessive stocks in the sample basis. And maybe now I answer our next question answer, but if you want, I answer this.
Let me quickly first go to Mansur and.
Okay. Thank you.
Agriculture is one of the key sectors of our economy, which ensures food and economic security of the country, as well as contributes to the labor and settlement potential of rural territories. Its contribution to the GDP is currently at 10% and expected to grow with each year. Our working population in the country is 8.5 million, out of whom 1.4 million or 60% work in agriculture. Agriculture in Kazakhstan has bright prospects for future growth. Our exports has been growing in terms of oil-bearing crops and meat. And when it comes to grain and flour, our country has managed to become one of the largest exporters in the world. We have to meet very strict criteria in terms of being competitive both in the domestic and international markets. That is why we believe that government oversight is very important for that sector. More than 70% of our territory is used for growing plants and breeding animals. And out of the when it comes to the lands used in agriculture, 70% of those lands are pastures. When it comes to crops, 39% of the output is provided by family-operated farms, 31% by large-scale producers, and 30% by subsistence farms. As for animal breeding, 70% is provided by subsistence farms, 15% by family-operated farms, and 13% by large-scale producers. Our key exports is grain, the exporting of which provides approximately $1 billion to our economy a year. It has done so for the last 10 years. Combined with flour exports, the share of those products is higher than 60% of the total exports. At the same time, grain exports has been going down, and since 2015, Kazakhstan has been out of the top 10 world's biggest grain exporters. Agriculture has seen more and more investment. That does it for my presentation for this question.
Thank you very much, Mansur, for this interesting profile of Kazakhstan. I learned a lot of new things. Umed, it's your turn for a very quick introduction to the people present here. What is Kazakhstan, what is Tajikistan, and what is the role of agriculture in the Tajik economy?
Thank you very much, Stefan. Colleagues, can you hear me?
Yes.
Very good. Tajikistan is a small country which is bordering with the Afghanistan, Uzbekistan, Kyrgyzstan, and China. And our country, more than 93% of territory are mountain areas. But our territories are also agricultural territories. We can say that more than 70% of population of Tajikistan live in agricultural area, and one of the main crops we have is a cotton, and we have also gardens. This is very important for our economy and one of the source of employment of the local population. Of course, the last time in Tajikistan, in the past 30 years, the level of usage of pesticides decreased, because now we are not dependent on Soviet Union country. We are not supplied by Soviet Union as it was before, but now we are under the risk to buy and control pesticides, which included in the list of prohibited pesticides of the Stockholm Convention. So for this moment, I can say that in the system of managing pesticides in Tajikistan, we need to pay attention for registration of pesticide. The system of permitted and unpermitted prohibited pesticides could be imported to Tajikistan. And also we have to determine the governmental structure who can be who can manage this process. We suppose it could be Minister of Agriculture together with the Ministry of Health and Committee on Environmental Protection. So talking about the obsolete pesticides, of course, it is a legacy of Soviet Union. Until this moment, we know that more than 200 storages, which became private for this moment, are not under the control, and we have to manage this process also. We can say that more than 50,000 tons of obsolete pesticides could be buried under the ground, and our task is to help the local population to deal with this problem. So another problem we can say, this is a problem of empty containers. which local population use for their needs without any risks on their health. So the system of managing empty containers are very important for as from the legal side and from the practical sides. We have to conduct educational trainings for local people how to deal with the empty containers. So this very shortly and briefly about our country and its importance, agriculture for our economy, and how we deal with the pesticides for this moment, and what kind of challenges we have. More detailed, I will describe in my presentation later.
Okay, Umed, thank you very much. So essentially, you already addressed the next question I want to ask our speakers. So the biggest challenge in Tajikistan with obsolete pesticides is obviously the 200 plus minus mini landfills, which you estimate could be about 50,000 tons of obsolete pesticides and soils. If there's nothing to add, I mean, you will have your presentation more specifically on that later on. So let me ask Mansur, where he sees is the biggest obsolete pesticides legacy in his country, and where are the challenges to manage it today?
The development level of agriculture has a major impact on the well-being of the country's population. It affects the structure of the social conditions of the population, the average income per capita income, the consumption of goods and services. You see, the majority of studies on the impact of pesticides on human health and risk analysis have been done in the industrially developed countries. A major issue is that oversight of compliance with national legislation that regulates labor condition and restricts the usage of pesticides is quite often done in inadequate manner. It's not done properly. It means that the conditions and current situation in the developing countries is usually quite different from what is described in the studies, and we have a larger exposure risks when it comes to hazardous pesticides. It means that small farmers in developing countries quite often do not have or do not use the necessary protective gear. Quite often what they will use is special backpacks that allows them to spread pesticides and which results in a high risk of contamination. Quite often it is difficult to limit the usage of such highly hazardous pesticides, which results in their widespread use by people that have not received the necessary training. What I'm talking about is that containers with pesticides often will not have any packages or any information on them. And besides, there are times when farmers or workers will not be able to read the information that's written on the containers, either because it has been translated into the local language or the workers are illiterate. National pesticide management systems quite often are weak and ineffective. As for the current situation, well, at this moment in time, we have phased out quite a bit of the obsolete pesticides and compounds which had negative impact on the environment, and phased in quite a few compounds that are effective and are way safer. And to conclude, I would like to say that in accordance with the country report on the use of highly hazardous pesticides in Kazakhstan, a total of 22 kinds of pesticides are prohibited, and pesticides are prohibited but remain to be used in the territory of the country.
So, спасибо.
Thank you. That does for my presentation.
Thank you, Mansur. Tinatin, you have already mentioned with regard to obsolete pesticides legacy, the big problem of Kyrgyzstan is that you have about 5,000 tons at landfills, but there is no real disposal or long-term strategy for the country, that there are also no central stores for it. Would you say with obsolete pesticides, this is the main challenge for Kyrgyzstan, or are there other obstacles?
After the inventory of National Department, Chemicalization Plant Department, supporting by international organization, it was really clear which storage site is needed, what is priority for each storage sites. For example, priority of Chikabat site, it is the most suitable for DEA and the RMP development. Finally, there is a good possibility that eventual risk management methods selected would be not entail off-site disposal, a great cost, so could be implemented if reasonable funding is obtained. For example, for Suzakbi site, it is clearly the greatest concern, particularly regarding the need for safeguarding work at the site. It is unclear how much, if any, pesticides in containers still remain at the site. However, there are clearly split pesticides, pesticide-contaminated soil. Also, there is possibility of conducting DEA and the developing IMP using funds from source other than FIRE project funds.
Before I said our problem about it is starting from Soviet Union period, and to determine this process in detail, we did mentoring 4 years ago, especially the widespread use of these pesticides in the last years. It caused the containing in the different regions without control. And in the 2019, we did mentoring, and I took participate in that mentoring directly. And after our mentoring, we saw tragic issues, and we realized that there was really problematic situations. I would like to share some information about our mentoring result, because this problem especially is directly over today's topic. In that mentoring, we took a sample from the different objects, from soil, from water, from different products, and also from the plants. And after testing these products in the laboratory, we determined that, especially in the plants, we determined the pesticide residue than 5,000 and 6,000 more than norm. It's really fantastic result. And also we determined that the pesticide residue for food products, especially we took milk product in that regions, determined 2 or 3 times than norm. And also after testing our soil samples, we determined that in that products, pesticide residue was POPs, persistent organic pollutants. And also some of them is related heavy metals. We determine copper, lead, arsenic, and other results. And we saw in that regions different situations, especially some regions. I would like to inform this information for you shortly. There is called Yevlach, and in that regions we saw 25 family, and these people were refuged, and they have come these areas from the Karabakh territory. And you know that till the last 2 years, this territory was occupied by Armenian army. And therefore, in the last years, these people has come to the different regions of Azerbaijan, and especially in the Yevlakh region, these people live the contaminated soils areas. They are not far from that areas, and they are not near. They directly live in that regions. And after our monitoring, we saw that in that region, people has different issues. They have different health problem, and especially most of people were cancer issues and diseases. And also we saw that these people has different social psychology problem, and therefore this problem is really hard to my country. And also within the framework of the pilot projects implemented by international organization, we can do to transfer the obsolete pesticides to transfer the jungle landfill. But unfortunately, the financial resource allocated to the projects were not enough for the full completion of the transport works. And after our monitoring, we determined, we inventoried 32,416 ton obsolete pesticides and organic pollutants. And the last of my opinion, I would like to say that to improve our national legislation is also effect over to solve the problem. And for this, we need the international experts to make our new legislation together. Thank you.
Javidan, just keep the microphone. We will have our last question. Please be short. Obviously, you are responsible with AFSA for the entire pesticide life cycle management. If you look at today's use of pesticide, what would be most important to improve to get agriculture to the best level, next level, which relies on less pesticides and less dangerous pesticides?
Thank you, Stefan. I think that I can say different problem about it. First of all, is that our farmers, especially local people, need educated about it, because when we were monitoring, we see that problem. The people don't know more information about the use the pesticides. They use pesticides on normal and besides, they throw the container of these pesticides on the field. Some regions, unfortunately, I'm obliged to say that they use this container in the life as normal, and it also affects their life condition, and therefore they have different health issues. And besides, I would like to make new container management system in Azerbaijan. It's also important for us because till today we try several times to make that system in Azerbaijan, but we started, but we can't get the result. And in my opinion, firstly, we should this project as pilot system in some regions. We make new collection points, and also we should change some points in our national legislation about it. And after that, the main problem is that we don't have the national disposal mechanism in Azerbaijan. Whenever we find the obsolete pesticides, we collect all them and to transfer jungle landfill. And next is question. We don't know what are we doing, and we just collect all these pesticides to the just one point. And for next, we are finding the solution. And I would like to thank the FAO project, Mrs. Tania, Mr. Stefan. They really help to make the national disposal mechanism in Azerbaijan. We have discussed about it, the national different factory, but I think we should make that system, and we provide that system continuing in the next years. Thank you so much.
Thank you. In my country, I want to indicate 2 points for reducing or also ecological management of use pesticides. As today from the presentation Mark Davis, it was clear this reckless use of pesticides and the fertilizers are putting the sustainability of food in the agricultural system at risk. We have to reduce using the pesticides. Over the past 20 years, the FAO Regional Office for Central Asia, in collaboration with national governments and the no-government organization, has implemented a number of programs, a number of projects to train farmers to build the capacity of extension service to promote and implement integrated plant protection. Integrated plant protection being promoted in my country because it is an ecological approach to pest management based on knowledge of essence of ecosystem as foundation for good crop management. Because very often now low numbers of some pests are necessary to maintain the population of natural enemies in the fields. But IPM strategy depends on varieties, the characteristic of the country, region, location, local agricultural skills, knowledge in the plant protection products available for farmers. This means that IPM must be developed and adapted to local conditions. Second important point, the organic movement began in Kyrgyzstan to develop. At the time, about 30 30 pioneer farmers are engaged in organic federation, organic agriculture. Today, biofarmer unities more than 1,000 certified farmers and offers organic products such as cotton, sunflower seeds, beans, medical aromatic plants, and dry apricots. According to experts, organic farming is more suitable to countries with generally small farms, cheap labor, and the storage of capital. Thus, organic farming may become for Kyrgyzstan perfect future. Maybe became, according, in fact, the Kyrgyzstan parliament just announced a plan to phase out all no-organic farming and the switch to 100% organic agriculture by 2028. Thank you very much.
Thank you, Tinatin. Mansur, you have already mentioned before several problems like weak training and understanding from farmers, problems with label packaging, that the overall system is weak. Is there anything else you would like to add on what are obstacles or what needs to be done in the coming years to bring agriculture to the next level in Kazakhstan?
Thank you. Basically, I would like to echo what just been said by my colleagues. I think that overall, a few actions are needed to be taken. First of all, we need to encourage the use of natural fertilizers. We need them to increase in volume. Of course, they are more expensive, but I think with higher competition, the prices will go down in the future. Number two, when it comes to pests management, I think we need to move away from using chemical compounds to newer technologies such as ultrasound, for instance. Third, we need to have better waste management. We need to be able to have more filtering. We need to do clean up. I think that this is the way to go. Thank you.
Umed, Tajikistan, you have the final words for the Central Asian countries. So what do you think would be important to bring agriculture to the next level in Tajikistan?
Thank you. I suppose that Tajikistan have more information about contaminated areas. And for this moment, I suppose we have to think how we are going to clean up the sites where, which contaminated by obsolete pesticides. And of course, we have to think about how to dispose safely of existing obsolete pesticides on Vakhsh polygon and Kanibadam polygons. The next challenge and the next step, and it's very important, I also mentioned registration of pesticides, and of course to deal with the legal issues of cleanup, transportation, labor protection, and creation list of prohibited and allowed pesticides. As my colleagues mentioned, it's very important to introduce to local farmers new technologies of pest protection, which could be based on bioprotection, and of course, raising awareness of the local people about the new possibilities and new technologies, how to deal without chemicals. Thank you.
Thank you very much. Thank you, Bal. A big thank you to all the speakers. This would close our introduction on what is Central Asia and what are the challenges Central Asia has related to the legacy of the Soviet Union from the massive overuse of obsolete pesticides, but also what needs to be improved to get further in towards a better agriculture. Now, as you know, the CHEF is funding currently a project which is implemented by the FAO. And we would like now in the next presentations before the coffee break and after the coffee break, present you different aspects, different activities we are undertaking, let you know where we are today, also where we still want to go. And the first presentation will be by Tania Santivanez, which will give you sort of a overall view, followed by various presentations from our consultants on specific aspects like bioremediation or empty pesticide container management.
Okay, so I would like to start by reminding everybody that the FAO mission is a sustainable world with food security, safety for everybody. In this sense, FAO, to be able to get to that challenge of food for all and a sustainable world, 2 years ago, we started working with a new strategic framework. That strategic framework has 4 fundamental pillars. The first one is better production, then better life, better nutrition, and for a better life. These are the 4 pillars for the transformation of the agroalimentary systems so that they can be more efficient, more inclusive, and more resilient. That's at a global level. We are working on this. This is a strategic framework we're working with. And at a regional level, we consider that taking these 4 pillars into account, we need to work with 3 big programs. The first one is related to small agricultures and empowering family agriculture. The second program is related to facilitating market access and transformation of agri-food systems. And then the third one is related to managing the environment resources, preserving biodiversity, and also the climate. So within this structure or within this program, we have a factor that is related to environmental sustainability. And it's in this section about environmental sustainability where we see or we focus on pesticide and fertilizer management. We work with agricultural plastic, soil pollution, and also all with a biological approach, bioeconomy approach. So why are we working on this in this third program? Why are we working on pesticides and pests? Well, because if we think of the agri-food system, we see how everything is interconnected. Transformation, investment, the food consumption. And since everything is interlinked, the use of pesticides, or the wrong use of pesticides, is going to affect directly our natural resources. It will contaminate the soil, the water, it will reduce biodiversity, as Mark already mentioned. But beyond that, if we move to this area of the agri-food system, because of that abuse of pesticides, we're going to have food with a high concentration, a high degree of these substances. And that is going to affect the market, the society, and people's food consumption. So from this third program in our region, we are working on pesticides, something within the program, because we consider that the use of pesticides is affecting the whole agri-food system. And this is why we are promoting what we call green agriculture or nature-positive production. And what does this mean? What does nature-positive production mean? This implies producing but reducing the contamination, reducing and avoiding environmental degradation. And also, this also implies decreased use of external inputs like pesticides, fertilizers, including energy. So the basic pillar of all these, of this green agriculture, or this positive approach, has to do with a holistic management of pests and of pesticides, but in a holistic way. We need to integrate everything. And what is happening in Asia and Central Asia and in general in Latin America and in all the regions is that we are managing these things in a separate way. Pesticides are on one side, the life cycle of pesticides, and then on the other side, we are managing an integrated pest management. So FAO wants to work on these two things in a holistic way. And so if we think about obsolete pesticide management, it is important that when we are working on this obsolete pesticides, our base are these two pillars, prevention and disposal. And when we talk about prevention, we're talking about improving registration, regulations, work on IPM, pest surveillance alternatives. And when we talk about disposal of these obsolete pesticides, we're talking about inventory, safeguarding, and destruction. And now we're seeing how necessary it is to work on soil bioremediation. And as a cross-cutting pillar with all these prevention and disposal, we have pesticide risk communication. And for these, FAO counts on a series of mechanisms, of tools, a lot of materials, so we can offer support to the countries that need to tackle these issues. We heard today our colleagues from the different countries about the big challenges that they face in Central Asia, like the huge volume of obsolete pesticides, land and water contamination, food contamination, and also the generation of a high volume of containers, of empty contaminated containers. Then we've also heard about the concerns about legislation for this prevention and for pest management. And many problems still related to contamination, poisoning, chronic poisoning. In this sense, since a few years ago, we've been working in a project that started being implemented 5 years ago. There are 4 different pillars in this project. The first one is related to safely destroying POPs and obsolete pesticides. The second one intends to strengthen the institutional and regulatory framework for managing pesticides, and the third one to finding new alternatives. So taking this into account, I want to mention where we are right now when it comes to, for example, the first pillar, disposal, right? In 2013, the project was developed, and there was like a structure proposed for pesticides disposal. well, 5 years afterwards, after working in the project for 5 years, and due to the high volume of pesticides, the nature of these pesticides, and the geopolitical situation that, for example, our colleague in Azerbaijan mentioned, all the problems that we have in the region, and especially due to the lack of infrastructures and the capacity to dispose of these pesticides, took us to the development of a strategy, a regional strategy, because we are thinking about obsolete pesticides in an holistic way. The first component would be the legal and governance frameworks. And the second one, technical options or infrastructure research that we need to work on in the region. And the third one, which is the most important one, the capacity development. We need to improve capacities. We need to improve the skills at a national level. And this strategy, this sub-regional strategy, takes place within a national context, and we have different action plans in each country. So in this sense, and within this framework, we've developed different works and different inventories in Azerbaijan, Kyrgyzstan, Kazakhstan. In Kazakhstan, we're almost done with the inventory. And as you can see, the figures are quite shocking, and we see how we still have these problems, and we still have problems with these pesticides. And we see that in the when we see the high volume of empty containers in, well, for example, Azerbaijan or in Kyrgyzstan, 130,000. In Kazakhstan, we don't have the final figure, and so it's very high volume in all these countries. So knowing all these, the project we've been working and trying to identify these products, and where we see that there's a lower concentration, we have to focus on the management of landfills and bioremediation and phytoremediation processes. And also management of empty containers. And of course, always working on the communication. So as in relation to the first topic in Azerbaijan, we started seeing some options. And among these options, we are still well, assessing the feasibility because it's only theoretical possibilities. We need, so far, we don't have anything specific, nothing at a practical level. So yes, we don't have any possibilities right now to work on this at a practical level in pesticide disposal. Then in Kazakhstan, we are hopeful that in the other 3 countries, Kazakhstan, Kyrgyzstan, and Tajikistan, with these projects from UNEP and UNIDO, we can work on these new projects, incinerators, and with that we can generate some solutions. We are also exploring the possibility to export these obsolete pesticides, but that is extremely expensive. So we continue with these, and as in relation to contaminated soil in these countries, in Kazakhstan, Kyrgyzstan, and Azerbaijan, we already have, we've seen some progress in phytoremediation and bioremediation. In Tajikistan, we're working in mini landfills, small landfills, and this year we're going to work in a bioremediation process as well. You will hear that in the presentations this morning. The idea of these is that there are big areas of contaminated soil, so we need to think of creating a working group that will help us solve the problem of contaminated soil in the region. We're working as well in safeguarding, and the upcoming month we will already delivered the Jangi polygon, which is being finished for safeguarding tasks. And in Turkey, we're going to work with collection and disposal of obsolete and confiscated pesticides. And in Kyrgyzstan, we're going to work in safeguarding and centralization of obsolete pesticides. And we will also work in empty container disposal. And Alexandra will talk about this also. And the second component related to strengthening the institutions, we've worked with in different actions, like review of legislation on pesticides, and we are developing a model legislation for a container disposal model. And so we are also working on strengthening the registration systems. In Tajikistan, for example, it's the only country in the region, and I would dare say the only one in the world without a registration system. And this is where we're working on these, and FAO is working with the World Bank to solve this problem. And in the third component, which is also essential to solve this obsolete pesticide problem, we have a sub-regional strategy for integrated pest management. It's a strategy for several years with different stages, and we're working in training and education, and we are trying to reduce the use of pesticides, applying the IPM. And we have a person in charge of this, Zsuzsanna. He will tell you more about all the progress that we've made in this sense. But only to give you some information, depending on the crops and specific pests, in these years, we can show how 68% of the use of pesticides can be reduced. So this is the work that we're doing, and this means that we can reduce even more the use of pesticides. There are alternatives, there are other possibilities, and we've been showing so with this project in the last few years. Here you have some examples of the high volume of actions carried out in the region. And this year we will start working in with field visits with students and also in universities. Finally, everything that I mentioned is covered in our website. We have a website for the project. You can visit it, and I encourage you to visit it, and you will see all the things that we're doing. And maybe we'll just insisting on something. Every year we have a report that we publish telling about our accomplishments every year. We also worked on a book for kids. And maybe just the last thing, I would like to mention that last year we started with some traveling seminars. And with these, in just 1 week, we get to different regions to talk about the hidden dangers of pesticides. And
so the next presentation is by Tinatin. Tinatin is professor at Turkish Manas University in Bishkek, and she's working for many years on bioremediation. A publication by her 2 years ago has triggered our attention because she had published an article on laboratory experiments on bioremediating POPs with fantastic results. But life does not happen in the laboratory, but on the fields. And so we asked Tinatin the last 2 years to see whether she can have the same results with POPs in the field, and also look, because a lot of the Soviet pesticides have been based on heavy metals, whether she can also try to understand how we deal with heavy metal contamination. And this year we will task her how she could deal with mixed POPs and heavy metals contamination.
Again, good day. My presentation is recently obtained results for project supporting by FAO. My project in-situ implementation of trials on microbiological remediation of POPs contaminated soil in Kyrgyzstan. As usually today, soil pollution by pesticides is a worldwide problem. Organochlorine pesticides are persistent in degradation, so they tend to bioaccumulate in the ecosystems. Currently, 50 storage facilities for obsolete banned pesticides exist in Kyrgyzstan. They hold about more 5,000 tons these chemicals, and they pose a severe threat to surrounding population, livestock, and the environment. You can see in almost every region in Kyrgyzstan, there are former storehouses and the landfills for obsolete pesticides. Also, these deaths of large population of sheep after drinking the water of rivers flowing through these zones. It was in Suzak storage facilities zone. It occurs 2007 year. What is bioremediation? To remove the pesticides, to restore of ecosystem, must be used ecologically friendly, economically viable, effective method. One such method is bioremediation. Bioremediation exploits the certain group microorganisms, the metabolism of certain group microorganisms. These microorganisms have unique ferment system. They can use the pesticide as nutrients, and they can completely mineralize them, or they can convert them. It is into decomposition products. In this study, we aim to develop a bioremediation approach for treating polluted soils, and that use agrochemical improvements and selected active degrading bacteria. A byproduct was tested in SITU field trials. This slide shows research design. You can see this former pesticide stored in Chimgorgan village in Kyrgyzstan. It was selected for a suitable place for testing the efficiency of our bioremediation approach. 3 conditions were tested. First, addition of fertile soil and the byproduct. Second, addition of fertile soil and the no byproduct. Control 1. Third condition, no fertile soil, no byproduct. The control 2. The treatment was applied directly to the contaminated soil. For byproduct, we have used 3 bacterial species: Stenomorphanus, Lysina bacillofusiform, and the Enterocloaca. For preparation of the land for conducting bioremediation, we used tractor. Tractor was used to plug the top of layer to depths of 25-30 centimeters. Soil samples were selected separately from each layer, from the 10, 12 centimeter and from 25, 30 centimeter layers for chromatographic and the microbiological analysis. Also, soil pH was accurately measured across the area. To create optimal conditions for bioremediation, fertile soil was added and mixed with the contaminated soil and irrigated with water to activate the local microflora and to reach the needed moisture capacity in the contaminated soil. We use 18 tons of fertile soil to 40 square meters plot. For preparation of byproduct for remediation, suspension of 3 selected bacteria were submerged cultivated in bioreactor lambda. 3 bacterial strains were cultured separately. Then the resulted bacterial suspension were mixed together to produce a single byproduct. Then this product was applied to the soil. Bioremediation condition in soil was monitored as moisture, as temperature, and the pH before the applying byproduct. Then we have to analyze, we have to know about the local microflora before byproduct application. The natural soil microflora was represented only 2 genera, Bacillus and Streptomyces. Both bacteria form spores, a feature that supports survival and the resistance these bacteria to adverse conditions. Also, soil samples were found to contain relatively low amounts of colony-forming units of bacteria, only 30,000, 38,000 per gram of soil. Now, this slide shows about soil bacteria after the 3 and the 6 months of byproduct application. PCR analysis of soil bacterial species after the 3 and the 6 months of byproduct application relieves the presence of a bacterial community that was based on the introduced byproduct species. Luziniform, Enterococcus tenomorphanus, also plus local microflora. Local microflora was found to be richer than before the byproduct treatment and consists of Delphia, alkali genes, Lusinobacillus bacterium, Bacillus tenomorphanus. This finding indicated that the bioaugmentation not only ensured the survival and the functioning of introduced bacteria, that also activated the local microflora. It is very important moment. This table indicated comparison of the soil pesticide concentration before the experiment. For example, for comparison with maximal permissible concentration, MPS. You can see some pesticide concentration, for example, alpha, beta, gamma, BH, concentration was 2.5 higher than MPS. The most pesticide concentration was several times higher than MPS. For example, Dedrin was 846 times higher. Endrin was 152 times higher. Ondrin was 45 times higher. This slide shows degradation of pesticide in soil. 10-12 centimeter layer. This soil received fertile soil and they receive byproduct after the 3 months. We use chromatographic results to compare, to analyze soil pesticide content after the treatment at a depth 12 centimeter. After adding the fertile soil, after 5 application of byproduct, the content of such pesticides is aldrin, gamma chloride, and the sulfan 1, and the DDD, 444-DDD, and the others had been decreased from the 68 or 69, 6 and the 297. But some pesticides, next moment it is degradation rate in control 1. This soil was received only fertile soil, no byproduct. You can see there is also intensive bioremediation observed. It is due to introduction of microflora in fertile soil and due to activation of local microflora. This in control plot 2, you can see very low degradation or almost all type of pesticides. Only 2 pesticides were degraded up to 40%. This degradation rate in soil at a depth 30 centimeter depth. You can see in this layer experimental plot, this soil was fertile soil byproduct. After the 3 months, only two pesticides were degraded up to 85, 88. Other pesticides were degraded low. This we have compared the pesticide content before application or after the 3 application by a product in the May and in December after 9 application by a product. You can see this last column. Almost all pesticides degraded up to 99%. In control, some pesticides still have high concentration. For example, endrin, endosulfan, endosulfate. Now it is in control plot. There are no fertile, no byproduct. It was high concentration of almost all pesticides. Then we have some tests to check about the phytotoxicity of soil after bioremediation. We plant some seeds of some vegetables and other plants. You can see after the 6 months bioremediation, this soil became more able for growing, for germination of seeds. It was achieved only 6 months after bioremediation. Also, we have some second part of project. It was screening of some bacteria resistance to heavy metal compounds. We have isolated, we have selected 3 or 5 microorganisms. They can be remove some metals. For example,
1 minute, please.
Some example, Lysine musiform can be used as universal biotransformation tool for many metal ions. Brevibacillus can be considered to remove the lead. Brevibacillus residues, Bacillus savensis can be used for removing arsenic ions. Conclusion, you can see we're giving some conclusion. We tested three conditions in terms of pesticide degradation. using the fertile soil and this byproduct, it was effective condition. Degradation rate was 1.5, 2 times higher than only fertile soil was applied, 5 times higher than when no fertile, no byproduct was used. Also, I can indicate this moment. We have removed obsolete pesticide within 6 months. Their concentration ranging from 0.40 milligram minimum and to 15.20 milligram maximum per gram of soil. Further research will be optimize the degradation conditions in a variety of soil types. Also, in exotic conditions with high concentration of pesticides. Also, with presence of heavy metal. Using these selected bacterial strains for study. Also, the product of degradation may be studied in detail because it is important. What is compounds, intermediate compounds will be during the degradation? It is unknown for us, so we have to in detail study this moment. Yeah, thank you very much for.
Thank you very much, Tinatin. Maladies. Vizdielili. Tinatin has presented us the step of bioremediation, and as you can see, she has achieved very substantial reduction rates, but we are obviously still at the level of several dozens of ppm, and human health levels are usually on the level of a few ppm, so we are still missing something. So the next presentation by Assil Nurzhanova will discuss phytoremediation as the last step, hopefully, to get contamination levels down to human health levels using phytoremediation. Assil is working at the Institute of Plant Biology and Biotechnology in Almaty in Kazakhstan. And she's working with her team already for many, many years on phytoremediation, not only on in the frame of obsolete pesticides, but in various areas. Assil, the floor is yours. 15 minutes.
Thank you. I want to present two problems. This problem, obsolete pesticides in Kazakhstan, and second, and method remediation. Inventory of obsolete pesticides carried out in 2010 and 10 years in 10 districts Almaty region. The 64 story houses discovered 3,052 ton pesticides, obsolete pesticides, from 350 kilogram was banned pesticides, and 21% pesticides container with labels and the different classes, and other pesticides were at a mix. We defined the concentration pesticides in soil around story houses, and shown the soil contaminated with some HC pesticides and metabolite DDT, and some soil around 24 story houses, some contaminated, some pesticides. The concentration exceeded EPS, and the territory is toxicity for environmental. This slide, we learned the migration of metabolite DDE through the food chain. So we investigated concentration of DDE in water and food and animal and plant food. So shown the DDE accumulated in product in food and dangerous to human. Next, we calculated the degraded DDT degraded in soil, created the three-field diagram illustration. DDT degradation pathway in soil is soil samples from different districts. So shown the soil in 3 districts degrade DDT absent. And 2 regions, districts, some anaerobic, aerobic degradation, pathway degradation DDT. One is of the important step to solve the problem is the cleaning of soil from pesticides. There are two ways, and physical, chemical, and the biological, and the biological, and the bioremediation, and phytoremediation. Phytoremediation is the common name, including different technology. The main technology for restoring soil contaminated source pesticides, the spot pesticides, and heavy metal is phytostabilization and phytoaccumulation. Phytoremediation have 2 strategies. The first strategy and the selection of plant in Kazakhstan grown 207 plants, phytoplants, for cleaning pesticides and pop pesticides near 10. Second strategy is optimization, contaminated condition, use agrotechnic method and different low molecular acid, and the last year used the plant microbe association and nanomaterials. The one disadvantages phytoremediation is long time. In the process of phytoaccumulation, necessary the utilization of polluted biomass. So, in last year, interest to phytomanagement. Phytomanagement is a technology, the process growing some energy groups on contaminated sites to produce clean biomass. It's experiment that this experiment contaminated. It's experiment shown that soil around the story house in Talgar district contaminated 24 pesticides, organochloride pesticides, concentration, some pesticides exceeded 500 times maximum concentration. For phytoremediation, we used the new plant, Miscanthus sinensis. It's Miscanthus sinensis don't grow in Kazakhstan. It's the new plant for our country. Miscanthus sinensis is new for phytoplant. The plant accumulated 15 organochloride pesticides from 15 some organochloride pesticides is hyperaccumulator for six organochloride pesticides. So phytostabilization for 3 organochloride pesticides, effete extraction for 5 organochloride, and accumulated Javidan. In Samarkand accumulated 9 organochloride in tissue. The perspective, some phytoremediation soil polluted with pesticides using endophyte and exophyte microorganisms to improve the effectivity of phytoremediation.
5 minutes, please.
The second result, phytoremediation soil polluted with heavy metal. Object was Miscanthus giganteus. We isolated from rhizome rhizobacteria. We studied the plant growth promoting characteristic and the tolerance to zinc and plumbum. Result some has shown the rhizobacteria, inoculation plant rhizobacteria increased the index tolerance and to prove the effectiveness of phytoremediation. Is the perspective the development technology from biomass, some of energetic plant, to получение biomass biochara for good biochara. It's will new project by support FAO. This project will begin in our year. Some have 3 tasks: the technical recultivation, field trials, and bio and phytoremediation, microbe preparate application in field scale, and cultivation seed plant on pesticide contaminated soil in greenhouse. This will be some 2 groups in the microbiological and physiology. Microbiological work with bioremediation for development bioremediation, and physiology will work with phytoremediation. Thank you.
CropLife International, the 2022 Global Agribusiness Forum in Brazil. So everybody is using figures from FAO, 20 to 40%. As you said, there is no proof, or at least we would like to have the proof, but their voice, it's so strong and our voice, it's so low, which means they will keep selling ideas that without the pesticides, there is no production. And if we combine the climate changes yield decrease from 10 to 20% in the next 10 years, and if we add 20 to 40% from the pest and disease, we come to figure that we'll lose 50% of the yields in the next 10 to 20 years. So let's think about it. Question to Tania. I just want to make sure that, did she say that it's 1,000 tons of plastic containers per year in Tajikistan? Or if I get some other figure? It is on the presentation, maybe the presentation can show. And also a question to the colleagues from the Kyrgyzstan. You said you add 18 tons of the fertile soil on the 40 square meters, correct? So it's about half meter deep of fertilizer, sorry. So it's 18 tons in 40 square meter?
We use fertile soil by stage. Every time mixing very well with the depth layer. Yeah.
So the fertilizer, the fertile soil was used to kind of increase of the bioorganism work that will stimulate their work. And also how we are sure that now when we mix the fertile soil and contaminated soil, it's biological way of thinking, definitely the percentage of the pesticides will decrease by itself because we have now new fertile soil, that it's clear.
Why we add fertile soil? Because as fertile, there are so many biodiversity of useful organisms, local microorganisms, other microorganisms. They functioning, they provide the ability of soils. When we use the fertile soil, every time on the plot, we have to mix it to the depths of soil. Watering, aeration. It was two fertile soil distributed regularly to depths of soil. After the mixing, aeration, it is for conducting microflora activation. Then, after the measuring of conditions, moisture, temperature, pH, it will be optimizing for bioremediation technology. For example, soil moisture must be 60–75%. Temperature 27. pH 7.4–7.6. After this optimization, we applied our byproduct. After applying our product, again mixing, again irrigation. Yeah. This technology is how I can see, can require a lot of time, a lot of human resource, because 40 square meter, it is maybe small area, but when you are working, it is not small, it is big area, because our bacteria will be work in this soil. We have to enough efficient distribution of byproduct.
Sasho, we had a blackout with Zoom, so I don't know whether Tania has heard your question on the empty container volume, so let me quickly answer that. We have made the work in 5 countries. Essentially, the more intensive agriculture, the more empty packaging. we have essentially two groups at the moment. We have Kyrgyzstan and Tajikistan with maybe 10 to 30 tons of empty plastic packaging at the end of the year. And then we have intensive Azerbaijan and Kazakhstan and Türkiye with because you have obviously to run a collection system and a container disposal system. This has been funded somehow, and this is easier if you have 5,000 tons instead of 30 tons, because the basic costs are always the same. Now on your first question, I think Mark is in better position to answer.
Yes, the figure of 20 to 40% has been around for many years. And I actually looked back to see if there was any scientific backing for that. It's very limited. And the fact of the matter is that when pesticides are being used, their effectiveness is not demonstrated or researched through randomized control trials. So we've seen some very good examples of randomized control trials in terms of the use of bioremediation and phytoremediation here. You do not see the same level of science in terms of demonstrating the effectiveness of pesticides. So that figure is ambiguous and dubious. But there is plenty of science that demonstrates that without the use of pesticides or with significantly reduced use of pesticides, you get equal yields. So those crop losses are not demonstrable in scientific trials. The other thing is that industry itself, using that figure, is implementing a strategy which has been demonstrated by industry over many, many years. It's the chemical industry, it's the tobacco industry, it's the oil industry. They use the science of doubt. So basically, anybody that comes up with science which contradicts their position, they throw doubt at it. They basically say, you know, that's not demonstrated, that's not proven, we have different data, etc., etc. So they introduce doubt into the debate, which then makes it much more difficult to argue against it. And of course, they have the finance and the lobbying behind them to be able to support their arguments. Finally, the point that you made, that in the face of climate change, in the face of all these other population growth and so forth, we need higher production. Pesticides are not going to deliver that. Because if you look at what I was saying in my presentation, where pesticides are actually undermining the ecosystems, the soil microbiome, those mechanisms are required in order to produce crops. You need to protect them and enhance them in order to sustain and improve your productivity. Science from the UK recently suggested that we have another something like 70 crops to produce if the current production methods continue. Beyond that, nobody can guarantee productivity. So basically, we are killing the mechanisms on which our crops depend in order to be produced. That is not sustainability. If you want sustainability in the face of climate change and population growth, and you want to continue producing food for the next 10, 50, 100, 1,000 years, then you need to be reversing what we've been doing for the last 50 and 70 years. And we need to put in place completely different mechanisms to grow and protect our crops.
As Mr. Mark Davis mentioned, we are now getting to the 400 million active ingredient, and every day, every year, it is increasing. You know, we are just talking about that we are getting more harm than use from pesticides. And we are in the 4 million active ingredients. According to our calculation many years ago, any idea that how many % of the insects as the main, you know, group of pests are pests? Any idea yourself, Mark?
I'm sorry,
how many % of insects?
Very
yeah, according to our calculation many years ago in Canada, it's 10,000 species totally. Agriculture, health, and everywhere, veterinary, up to 3 million species of insects. That already we have 1.2 only discovered, because I'm an entomologist, toxicologist. And it is increasing, and they are talking, but the world, agencies, they don't do anything really. And we need more stronger actions really from WHO and FAO to do something, because tomorrow I'll talk about highly hazardous pesticides. They are doing very bad harms. Lots of suicidal, lots of problem, worker, and then these things. And I think there are not enough actions. And we are now concentrating on SITU, I think is going. Other conventions, BRS and things are not doing well really. Thank you.
Okay, thank you for this interesting addition, and also giving again another dimension. Are we really fighting with a gun at some sparrows? So thank you very much. So it's time for coffee break. The next presentation is by Ulughov from Tajikistan. As I mentioned earlier, Umedjon is the project director from NGO PESTICIDE, and is probably the organization in Tajikistan, besides the ministry, which is most active and most involved in dealing with the legacy of obsolete pesticides in Tajikistan. Umedjon will give us a short overview on one of the main challenges in Tajikistan, the mini landfills. He will tell us what is a mini landfill, and obviously what risk it is for then the surrounding population, and what kind of information work we have been doing with the local population last November, as has already been mentioned by Tania. So Umedjon, the floor is yours.
Thank you very much, Stefan. Thank you for being here online. Of course, it's pity that I cannot be in Zaragoza because of visa. But any case, being online for me, it's very honest, and I would like to present you some of the problems we have and we are dealing during the 13 last years with NGO PESTICIDE, which I represent. And thank you, Stefan, for introduction. Also, I have to say that NGO PESTICIDE, as a member of HPMI, which is our very active in Central Asia, dealing with the POPs issues. First of all, I would like to present a content of my presentation. I would like to start from the history of this problem and go to the mini polygons and the problems which is mini polygons come through the local population. How many obsolete pesticides now we have in Tajikistan, and separately I would like to mention village number 1, Jaikhun district, Khatlon Oblast of Tajikistan. And of course, a bit I will tell why awareness raising campaign are important for our country. So the next slide, please. The history of mini landfills in Tajikistan starts from 1913s, when our country was chosen for producing monocultural cotton, and the Soviet Union government decided that these territories have to be expanded, and this agriculture cotton have to be everywhere. And of course, in order to produce more and more cotton, it was needed a lot of pesticides, and agriculture. The people who was busy with agriculture, they didn't know about how the pesticides influence on their health. And of course, we have to say that starting from 1916s, in Tajikistan, the total amount of area busy under the agriculture was decreased, and centralized planning and supplies of pesticides led us produce 1 million ton of pesticides. But the government of Tajik Soviet country decided to increase the volume of cotton, and total number of produced harvest should be 1.5 million ton. For this, there are a lot of people who was involved, and unfortunately, until 1970s, we didn't know how the pesticides could influence on the health, and that's why we used DDT, Thiodan, Lindan for these purposes. And unfortunately, until 1970s, we didn't have any special landfills for disposal of obsolete pesticides. And also, of course, we didn't have information how the pesticides could influence on the health. Next slide. We have to say that local employees of the mini polygons, warehouses, they buried all their obsolete pesticides on the territory of the warehouse. Now we call them mini landfills. And during Soviet period times, these warehouses were isolated. People didn't have access to these territories, and the access was limited. After the USSR collapsed, unfortunately, most of the warehouses was privatized, and land of these warehouses was sold out to the local population. For example, in Jami, we have an example where people are living still there and suffering from these territories. And for this moment, we also have information that people removing soil by themselves and putting this obsolete pesticides and contaminated soil to the water resources, unfortunately. Our organization was involved in these problems since 2006. Together with the Committee on Environmental Protection, we investigated more than 200 mini landfills throughout of Tajikistan, and the main database now are available for all interested and attracted people. Next slide, please. This is some examples where we are working now. For example, I will start from village number 1 in Jaikhun district. You can see the concentration of DDT here, 100 times more than it should be. This is standard warehouse which we have in Tajikistan. Previously, there are 4 families lived here, but according to the project of FISD, which was implemented in 2017, all families was resettled, but territory still contaminated. And thanks to FAO, we are starting a process of cleanup this mini landfill in 2023, and I hope that people will have a chance to build here new houses, and soil will be free from contaminated pesticides. Next slide, please. Jamaat Ziraki Kulab, you can see here in the picture some pesticides, which is a legacy of Soviet Union. Nobody cleaned up this territory during 30 years. We determined here, except of Thiodan, there are a lot of arsenic. You see the concentration 63,000 times more than it should be. And we find out more than 20,000 empty containers of obsolete pesticides, which is related to Chinese production. And we removed all of them October 2018. Thanks to European Union, they've financed this cleanup action. Now this warehouse completely cleared, and owner is using this warehouse for commercial purposes, not for food saving purposes, of course. Next slide, please. And the next example, you see this is a former warehouse which was destroyed totally, and people build up the private houses, and one of the families couldn't live here because of smell. It's a very bad smell in the summertime, and we decided to see what they have. And laboratory tests shown us a high concentration of DDT, and we removed more than 130 tons of clear pesticides, which was repackaged, and about 500 tons of highly contaminated soils, which was also removed. You can see how many people are affected from this warehouse on the map. That is a new village, which is people trying to build up the houses. The cleanup cost about 68,000 USD. Cleanup action was conducted in January 2020. Next slide, please. And the last example, it is a totally another situation. This is not warehouse, but former airport, which was used for defoliation of pesticides. And most of pesticide was removed to another side of the river, bank of the river, and was buried there. And people try to build up a new road, and they find out these pesticides, and they ask us to come and investigate it. We conducted in January 2020 our cleanup action and removed more than 250 tons highly contaminated soils and about 10 tons of pure pesticides, which was also repackaged. The cleanup action cost about 50,000 USD. The next slide, please. You will ask us how many their obsolete pesticides could be on 200 mini polygons. We can get only average volume of pesticides. Now we know it is 400 tons per each side, and that's why, sorry, it's not 250 tons per one side, and now we're making conclusion that there are about 50,000 tons could be buried in the mini polygons, and they have to be cleaned up. Until this moment, our organization cleaned up 6 sites. I know that I know the FASD cleaned up also 2 sites. Committee on Environmental Protection was involved, but all contaminated soils and pesticides are now removed to Vakhsh landfill, which is very alone. And we tried to build there a small warehouse, and we put there our all collected waste until it will be disposed appropriate way. Next slide, please. Going to the project which we are going to do with the FEO, I have to say that village number 1, situated on the south of Tajikistan, very close to Afghanistan, named of district Jaikhun. This was 1 hectare land before used for Republican warehouse, formerly in Soviet Union used appropriate way. But as I mentioned, a lot of pesticides were buried on the territory of this warehouse. We investigated and came to the result that investigation of 2018 made by FAO expert and investigation of 2022 made by us, the result is same. It's still this mini landfill should be cleaned up. I have to say that very close to this mini landfill, there are 2 channels, and 2,000 people are using this water for drinking purposes, unfortunately. And it's a risk that the water comes through the land, and we have to close these streams in order to not get people to use contaminated water. And now these activities will be done thanks to FAO. Next slide, please. For this moment, for PESTICIDE with the FAO international consultant drafted a project which based on the results of research 2018 and 2022 All laboratory analysis was done in European laboratory. We investigated for metals, hydrocarbon, organic chlorinate pesticides, polycyclic aromatic hydrocarbons, and etc. That's all information available for the Committee on Nature Protection, and we ready to start our next cleanup action in April 2023, if everything will be clear. If not, we are going to conduct it only in October because of the weather conditions. That's our plan for the future. Also, we have to say that according to methodology, we divided area on the 5 blocks, which you can see on your screen, and we got 10 samples, developed cleanup scenarios, and of course now budget also for excavation and removal for village number 1 landfill are ready. We have to say that all contaminated soil, and if it's needed, pesticides which will be repackaged, they will be removed to the washed landfill. Of course, we will try to use skips for these purposes because of budget limitation. I suppose it's a new idea for us because we didn't use it before. It's idea came from our international consultant, and we support this. But contaminated soil will be removed by big trucks. Also, we are looking for collaboration with Jeff UNEP project number 9421. They are also looking for some option of disposal of obsolete pesticides. Now we are thinking about option number 2 to use cement kilns for disposal of obsolete pesticides. During the project we have done with the Tania and Stefan, and with our local FAO office, we conducted awareness raising campaigns in 4 big areas of Tajikistan: Dushanbe, Bokhtar, Jaikhun, and Tursunzade. Most of our people in Bokhtar, Jaikhun, Tursunzade, they participated and they know about these problems. Some of them are new people in these questions, and of course it was a lot of questions. All information campaigns was conducted from 7 until 11 November 2022, and if you will show the next slide, we disseminated all materials in Tajik and Russian language, and of course we got participants' feedback. For example, it was 2 options where people say that pesticides are negatively affect on the public health, and from another side, people have to get more information about risks of using pesticides, and this information should be available for local school children also, and we have to work with the teachers. Also, the people say that using the pesticides could be one of the barrier for local experts, because a lot of lemons of Tajikistan in Jaikhun district goes to the different countries, and for example, European Union standards are not allowed to export lemons, for example, to European Union because of high concentration of nitrates. And of course, people are looking our actions, cleanup actions, and they are ready to support us in our activities. This is very short information about Tajikistan, what we are doing now. I suppose that we are only organization in Tajikistan who are busy with this problem, and thanks to different international organization, FAO, UNEP, FSD, European Union, and other organizations that they are supporting local initiatives in order to make our earth more clean and more available for our population. Thank you.
Thank you very much, Umedjon. And
oh, sorry,
sorry,
I didn't tell about the future plans. Yeah, of course. Maybe I told it we are going to excavate mini landfills, and of course it will be for us. It will be interesting to excavate village number 1, and of course it will be site assessment on the risks on mini landfills with FSD. We are going to conduct additional cleanup of sites and of course continue raising campaigns. Thanks. This is all my contact details. If somebody wants to contact me, thank you very much. I will appreciate for your questions, and I'm ready to answer your questions. Thanks.
Thank you very much, Umedjon. And I think your presentation clearly shows that if people are not aware of the risks and do not understand what pesticides are, they come up with ideas like, let's take it out of the store and bury it in the ground besides. And then obviously we have a lot of work to do 20 years later. I mean, unnecessary work, unfortunately. Thank you very much. I want to introduce the next speaker. We have already repeatedly, I think yesterday and today, discussed the whole question of what we do with the pesticides container once they're empty. The problem is they are usually very high quality plastic, and there's a big temptation for the farmers to reuse them for storing water or crops and so on. And obviously, international crop protection industry already for many years is working on that. Our next speaker is Alexander Efimkin. He's living in Russia, and Alexander has been establishing the Russian empty pesticides container collection system. The work with Ecopole he initiated in 2015, and now 7-8 years later, Ecopole has a national collection rate of around 50%, so about half of the empty pesticides containers in Russia are collected back. So Alexander is obviously a person who knows the challenge that you start at zero and how to get 200% from his own life experience. Alexander, the floor is yours.
Hello, everybody. Good day to all of you. And Stefan, many thanks for this introduction. So I'm going to talk a little bit about the container management system. So the system to collect and dispose the containers out of the pesticides. And my presentation consists of the 4 parts. The first one is about the main goals of this container management system. The second is much more about the details, what is CMS itself. And the third, this is the CMS experience, which is available from the more than 25 years of operations in the world. And finally, I will explain what do we do in the Central Asian countries and Turkey as well. So let's start. So what are the goals of the container management system? So firstly, I would like to say that due to the pesticides evolution, let's say in the form of it's consistent from powder to liquid at the end of the previous century, it also influenced the change in terms of the packaging from the paper bags and the wooden boxes to the plastic containers. And since that moment, the disposal of these containers became the problem for the farmers and for the countries as well. So that's why the international crop protection producers, they included container management as a part of the pesticide product life cycle. And you can see it as the picture on the screen, the circle with the container management in it. So The following major goals for the container management system are, first of all, this is to prevent legacy volumes of the pesticides packaging because of the annually generation of the waste out of the applying of the pesticides. The second one is to minimize the health risk due to the container reuse. The third one is to respond to farmer requests to relieve them from the empty containers, because as of now, most of the farmers don't know what to do with these containers. For the very first years, they were lucky to use them for the storing of the some kind of the spare parts of the some fuel and so on. But with the annual generation of more and more containers, the much more demands arise in terms of the taking these containers back from the farmers somewhere. The fourth one, this is respond to increased demands to protect the environment from plastic waste, because the plastic waste, even being buried, is not being continues to be being in the landfill, in the land, and therefore it should be safely recycled or disposed in a appropriate manner. And the last but not least, I would like to underline here, this is elimination of the container reuse by the counterfeiter. In terms of the Central Asian countries, counterfeit is a problem for the pesticides, because a lot of the pesticides are being counterfeited by some organizations, and therefore it's also a big risk for the health and for the environment itself. Therefore, the less containers are being presented at the market, the less risk to use this container to be refilled with a counterfeit product. So let's go to the CMS itself. Here you can see the big scheme of the container management system. However, it's quite simple. It consists of the two parts. The first one is about collection, and the second one about the safe disposal. However, it depends on various conditions from country to country, including the waste legislation framework existed in the country, logistical costs, and the proximity to the farmers from the collection centers, and also the treatment infrastructure. So the general container management scheme is presented at this slide and starts from the answering the question, either the rinsed containers being classified like hazardous waste or non-hazardous waste. In case you will answer yes for this, so the farmers usually can bring them to the collection points. In case the containers still considered like hazardous, usually nobody without the permit can transport these containers, and therefore the different method of the collection should be used, such as pickup on the farm's locations. Sometimes both of these options being used in the country, and for example, for large farms, they organized the pickup of the containers exactly from this farm, and for the smaller locations from the smaller farms, the farmers themselves bring the containers to the collection points. Then the containers, as soon as they will be collected, they need to pass the processing period. They should be shredded, and then they should be washed enough to remove from the dust, from the mud, and from the labels and so on. So in case the volumes are quite enough, considerable to be to use them for the recycle industry, and based on the condition that the recycle industry exists in the country, so those containers should be recycled, and then they could be they could be used as the raw materials for the end users. In case the volumes are not enough, so the only option probably is to incinerate these containers or the co-process somewhere in the cement kilns or in the metallurgical plants in case they are available. And then you can recover the energy out of these containers, which is also quite good. And in case both of these options are not available in the country, the only option to remove from these containers is just to export it somewhere to the country where the recycling or the incineration or co-processing is available. And on the right side of this slide, you can use the examples of the end uses for being done from these containers. And here you need to understand that there are two main restrictions for use of these containers as the raw materials. The first one, that the end users made from these raw materials, from these containers, cannot be used in the food industry. And the second, and that the end users should have limited contact with their human skin. So that means that most of these end users are being done for the construction purposes or for some underground or involved purposes. So they're not contacted with the skin of the people, and they're not used in a food industry. So as I mentioned, that there is quite a huge experience of the container management system. So it's the container management system is more than 25 years old, and right now there are more than 60 countries all over the world use the container management system in their countries. And so here you can see the extract of out of this experience. First of all, these are the prerequisites for the successful implementation and sustainable development of the container management system. And here, this is about the strict regulation of the extended producer responsibility and the farmers. In terms of the extended producer responsibility, this is much more about the putting the obligation on the producers and the importers of the pesticides to collect and recycle the empty containers. And in terms of the farmers, this is the obligation to rinse the containers and hand them off for the recycling. Then we're talking about the commitment. Commitment is also very important because here we're looking for all of the stakeholders. And the main are the following one. These are the government institutions who are in charge of having the legal framework which can enable and enabling the development of the container management system. Then we're talking about the producers and the importers of the pesticides who need to will and finance the management of the container management system in the country. And finally, these are the farmers to be motivated by to be motivated for rinsing the containers out of the residues of the pesticides and bring them to the collection points for the further recycling. In terms of the launching of the container management system, the main approach is to pass 3 steps in order to launch the container management system in each of the countries. First of all, you need to have some kind of the analysis, which is called feasibility assessment, where you obtain a lot of the information regarding the current legislation in the country with regards to the waste management and especially with the pesticides packaging. Then it's about the crop protection setup in the country, and that's about the companies, the crop protection producers and the importers being presented in the country, the distribution network, how it is organized, and also about the volumes of the pesticides and the packaging being generated each and every year. and also about the treatment infrastructure, which is available in the country, which is not, and what are the options to dispose the empty containers. As soon this feasibility assessment will be done, and as soon that all the stakeholders will be convinced to go further, so this is the time for the second stage. This is the pilot launch of this project, where just part of the country, probably 1 or 2 regions, are being selected, and where the collection of the containers is being started exactly from the farmers of these regions. And then with a constant improvement and development of this container management system, the system itself is being enrolled to the whole country. So these are the 3 stages. And the another one part of the experience that you need to look at the container management system, not just the system to collect the containers. It's quite bigger, I would say, quite bigger options exist to use the container management system with the years. And the experience of development of the container management system in the different countries just prove this. So first of all, you are starting with the pesticide containers. Then you can collect not only the pesticide containers, but also the obsolete pesticides and its packaging. And then you can also collect the other agricultural plastic waste, which is the volumes of it are much huge rather than the volumes of the pesticides containers. So all in all, this is the, I would say that this could be the total decision for the collection and the safe disposal of the agricultural plastic waste out from the farmers. So in terms of the things we are doing in Central Asian countries and Turkey, here you can see the columns with the steps being done, being already executed and being in the process in each and every country. So talking about the Azerbaijan, the feasibility study has been already done. The working group to launch the pilot activities has been established already. And right now, this is the work in the process to sustain the container management system in terms of the understanding what does the legal framework need to be improved and how, what will be the operational process to collect and dispose the containers, how this process will be financed, and what will be the goals and how we are going to measure the success of implementation of the container management system. And as soon as it will be done, we're assuming to launch a pilot there. In terms of the Kazakhstan, it's more or less, it's very simple to from one country to another. However, I would like to underpin here that each country is a unique country with their unique infrastructure, and therefore you can have the general recipe how to implement the container management system. However, you need to put a lot of the intention for the details. And here, when we're looking at Kazakhstan, we see more or less the same steps. So the feasibility study has been finished less than 1 month ago. So we're working on the establishment of the working group, and then in order to sustain the CMS. However, there is an option right now to include the agricultural plastic waste already at the very beginning of the pilot activities of the container management system, and we would like to try to do it already in Kazakhstan. In terms of Kyrgyzstan, the situation is a little bit different. So the feasibility study has been done, the working group established. Right now, we would like to test the pilot activities already in order to understand what are the options for the collection and what are the options for the disposal of the containers. That's because of the quite small amounts of the containers being arrived each and every year in this country, and the quite poor infrastructure of the recycling of the plastics, especially for the pesticides containers. And as soon as we understand this, there will be the option to understand how what will be the tasks to sustain the container management system, and we will be ready to launch a pilot. In Tajikistan, it's a little bit different as well, just because we're in a different time frame. So as the feasibility study has been done and the working group is established, however, the further work is just in the progress. In terms of Turkey, this is also quite different from the other countries. So in Turkey, there was already at least one attempt to organize the container management system. However, it did not fly, unfortunately, for the various reasons. And from another point of view, Turkey is the biggest country in terms of these 5 countries, in terms of the containers being generated on an annual basis. Therefore, right now, there is also the initiatives coming out from the institutions, government institutions of Turkey and local municipalities to collect their containers already. And FAO is helping to support the collection of the containers. During this year, the quite significant amount of the containers has been purchased by FAO and provided for the containers collection in this country. And we're looking closely for the results of these activities during this year, and would like to continue with more development of the container management system in the latest period. So we still understand that we need to have all the stakeholders in place in order to develop the container management system. So all in all, this is a quite big work to be done in these countries. We are not already in the beginning of this story. However, as soon as we did the first step, we are on the position to make the second, third, and the other steps. So this is all for my presentation, and I will be quite glad to answer any of your questions. Thank you.
Thank you. Thank you very much, Alexander. We'll park questions till the end of the session. So we have still another 2 presentations to go, where we increasingly go over to better agriculture practices. Now, a special challenge in agriculture is there is a whole class of highly dangerous pesticides. Abbreviation we use is HHPs, highly hazardous pesticides. They are unfortunately still in use in many countries. And one aspect of our work was also to assess in the 5 countries the highly hazardous pesticides. Are they still in use there? And so this will be presented by Alejandra. Alejandra is our consultant. She's stationed in Bolivia, but is just on the verge to move to Chile. And Alejandra has been working for many years in analyzing, in the frame of the Rotterdam Convention, registrations list for the presence of highly hazardous pesticides, but also then what are the next steps to phase out these dangerous pesticides and substitute them by alternatives. Alejandra, the floor is yours.
Good afternoon to everybody. Thank you for the presentation again. My name is Alejandra Loayza Guzman, and today I'm going to talk about What are highly hazardous pesticides? Next, please. How they should be managed. I'm going to talk about the assessment of HHP I carried out in Azerbaijan, Kazakhstan, Kyrgyzstan, Tajikistan, and Türkiye, about the importance of carrying out an HHP assessment, the opportunities and challenge. What are the next steps after the identification of HHPs, the prevention of new HHPs, and final recommendations for every country. Next, please. To begin, it's important to define what are the highly hazardous pesticides according to the International Code of Conduct on Pesticides Management. These are pesticides that are acknowledged to present particularly high levels of acute or chronic hazards to health or the environment according to the internationally accepted classification systems, such as WHO or GHS, or their listing in relevant binding international agreements or convention. In addition, pesticides that appear to cause severe or irreversible harm to health or the environment under condition of use in a country may be considered to be and treated as highly hazardous. Next, please. To summarize, the FAO and WHO joint meeting on pesticide management. Next, please. Recommended that highly hazardous pesticides, highly hazardous pesticide should be defined as having one or more of the next 8 criteria, characteristics. Criteria 1, pesticide formulations that meet the criteria of classes 1A or 1B of the WHO recommended classification of pesticides bad hazard, or criteria 2, pesticide active ingredients and their formulations that meet the criteria of carcinogenicity, categories 1A and 1B of the globally harmonized system on classification and labeling of chemicals, or criteria 3, pesticide active ingredients and their formulations that meet the criteria of mutagenicity, categories 1A and 1B of the GHS, or criteria 4, pesticides active ingredients and their formulations that meet the criteria of reproductive toxicity, categories 1A and 1B of the GHS, or criteria 5, pesticides active ingredients listed by the Stockholm Convention in its annexes A and B, and those meeting all the criteria in paragraph 1 of Annex D of the Convention, or criteria 6, pesticides active ingredients and formulations listed by the Rotterdam Convention and its Annex 3, or pesticides listed under the Montreal Protocol, or last, criteria 8, pesticide active ingredients and formulations that have been shown an high incidence or severe or reversible adverse effects on human health or the environment. Next, please. In this sense, the highly hazardous pesticide management includes the identification of HHPs. In order to identify highly hazardous pesticides in use, the list of registered pesticides should be examined against the 8 criteria mentioned before. For criteria 1 to 7, there are reference lists and related guidance that can be found on the internet. But assessment as to whether an active ingredient or formulation would fall under criteria 8 is more complex because this depends on the actual situation of each country. After it has been identified which HHP are used in a country, the next step is to assess the risk that these products are posing to human health and environment under the condition of use in that country, and review the needs of these products, taking into consideration available alternatives for this. Finally, mitigation of risk of HHP currently in use in a country. The main lines for risk mitigations are ending the use of a product, restricting the use, changing formulations, or changing their uses. Selecting the most appropriate options will vary from case to case and will depend on levels and country needs. Next, please. In the context of the project life cycle management of pesticides and disposal of obsolete pesticides in Central Asian countries and Türkiye, for the identification of highly hazardous pesticides in Azerbaijan, Kazakhstan, Kyrgyzstan, and Tajikistan and Türkiye, I use the identification toolkit developed by FAO, which allows to enter data about pesticides' active ingredients or their formulation in each wide field. Like here, for example, we have alpha-cypermethrin. Next, please. And then check if the entered information meet any of the criteria indicated before: acute toxicity, carcinogenicity, mutagenicity, reproductive toxicity, Stockholm Convention, Rotterdam Convention, Montreal Protocol, and high incidence of adverse effects. Next, please. Our results, I identify 107 pesticides active ingredients as highly hazardous pesticides, 22 highly hazardous pesticides in Türkiye, 28 in Azerbaijan, 22 in Kazakhstan, 20 in Kyrgyzstan, and 15 in Tajikistan. Next, please. And here in this table, I present the more relevant results. The pesticide active ingredients that meet more than one criteria, for example, venomil, that meet 3 criteria. As we can see too, most of them meet criteria 4, that is reproductive toxicity, like linurone. Then these ones are followed by the pesticide active ingredients that meet criteria 3 and criteria 4, that are mutagenicity and reproductive toxicity, like carbendazim and propinef. Next, please. The identification of highly hazardous pesticides represents opportunities and challenges to the countries, because with this, the risk could be reduced by different lines. For example, by the progressive banning of HHP and the promotion of alternative based on agroecology. But during the identification, some problems arise, like the lack of information. For example, during the assessment I carried out, the project team couldn't find local data about criteria 8. Other problem was that the identification was made only with the registered pesticides, but not with the illegal products that are used in the countries, because once more, there are not an accurate information about quantities and type of products. Last but not least, an important observation is that international research about hazard of pesticides continuous. And that is why other criteria might be added to the original 8 criteria. This could be, for example, endocrine disruption and toxicity to pollinators. Next, please. After the HHP identification, there are 4 steps that should be followed: the risk assessment, the mitigation of risk, the definition of an action plan, and the prevention of future HHPs. Next, please. In general terms, the action plan must include the main steps: identify which registered pesticides are to be considered highly hazardous pesticides, take stock of the current uses of these highly hazardous pesticides and the reason for their use, determine to what extent their use is actually needed, determine risk and condition of use, selection mitigation measures, and monitor the effectiveness of the mitigation measures. The plan should also answer the questions: what to do, who does it, how to do it, when to do it, and where to do it. At the same time, the plan should emphasize the mitigation risk measures. Next, please. Finally, to prevent future problems with highly hazardous pesticides, the registration system for pesticides may need to be revised. This might involve definition protection goals and an acceptable risk in pesticides legislations, strengthening of registration procedures, adding registration considerations based on the HHP criteria, and proactively favoring registration of products that pose less risk where such alternatives are viable and available. Enforcement of pesticide legislations might need to be strengthened to prevent illegal production, importation, trade, and use. Extensive training programs for pesticide retailers and users on correct selection on products, on proper use will help to reduce risk. Surveillance systems need to be put in a place to monitor use of highly hazardous pesticides and the effectiveness of risk mitigation measures. Next, please. Now, to close my presentation, some general recommendations. Strengthening pesticide management should include monitoring system in each country. Countries should reduce the highly hazardous pesticide risk by ending their use, restricting their use, changing formulations, changing packages, or changing the use and developing alternatives to highly hazardous pesticides. The principal measure of highly hazardous pesticide prevention is review the registration system, review pesticide legislations, as well training and surveillance. Promote the use of alternatives for highly hazardous pesticides like integrated pest management, integrated vector management, and organic agriculture. Promote the substitution of highly hazardous pesticides by less hazardous pesticides. Promote the training and raise awareness of different actors on highly hazardous pesticides. After the identification of HHPs, authorities should implement a risk assessment and risk mitigation measures. The best way to deal with highly hazardous pesticides is prioritizing those highly hazardous pesticides that need special attention. This prioritization should be based on dialogue and agreement between the authorities involved. That's all my presentation. Thank you for your attention.
Thank you very much, Alejandra. That was a very nice summary and introduction into the problem of HHPs. And a smooth handover to our last presentation of today. You mentioned as one of the alternatives to HHPs are improved agriculture practices like IPM. And I would like to give now the floor to Zsuzsanna. Zsuzsa is working with FAO based from Budapest, and she's a specialist for IPM and also for climate change resilience within FAO. So, and Zsuzsa will introduce you into what is IPM, but also share with you the results we did in various trials in various countries within the project. Zsuzsa, the floor is yours.
So good day to everyone, and thank you for joining to our session. I think our project shows really interesting results on the field. And throughout the day, you had a chance to hear several aspects, how our project supporting the life cycle management of pesticides. And as a closing presentation, I would like to tell you a bit more about the work that we are doing to promote alternative practices to reduce pesticide application in the region, and in general help the farmers in the region to have a more sustainable agricultural practices with the aim to avoid further generation of obsolete pesticides and move forward to more resilient agricultural systems. Next slide, please. One of the most effective ways actually to avoid generation of obsolete pesticide is to prevent the pesticide use at the first. So in that way, they don't have a chance to turn obsolete. We all know and also heard from various presentations today that the use of pesticides comes with various amount of risks, which we have to tackle, and one of our main goals to build more resilient and sustainable food systems. I collected the main risks, and let me shortly go through them to bring to your attention how it can impact on our health and environment. Even today earlier, it came as a subject that all of the pesticides have a serious risk on human health. They can have acute and chronic effects, including skin irritation, respiratory problems, headaches, nausea, and some other cases like cancer and reproductive disorders. And they can enter to the body through ingestion, inhalation, and skin contact. Even some cases, which is one of the main problems, people use them to harm themselves, and therefore their regulation should be further enhanced. They can have several serious environmental risks and can have negative effects, among others, to the soil, the water, the biodiversity, and harm beneficial insects and animals. Let me bring some further details on that. The pesticide can seriously harm our soils, as the capacity of the soil to filter, buffer, degrade, and immobilize and detoxify pesticide is a function and the quality of the soil. And soil quality also encompasses the impact that the soil use and management can have on water and air quality and on human and animal health. The presence and bioavailability of pesticides in soil can adversely impact human and animal health and beneficial plants and soil organisms. Pesticides can move off-site, contaminating surface and groundwater, and possibly causing adverse impact on aquatic ecosystems too. These chemical substances designed to be toxic to organisms that affect plants' growth, such as fungi, insects, or weeds. However, while pesticides help farmers to grow food in more intensive and simple ways, this generates many problems and cause the death of many wildlife species, including mammals, earthworms, and pollinators. The pesticide-intensive agricultural models has been identified as a major cause of biodiversity loss, not just in our region, but worldwide. Beside the environmental and human health risks, the pesticides can also create economical risks because they are expensive for farmers to use, and their overuse can lead to the development of pesticide-resistant pests, which can result in crop losses and reduced yields. And one important thing actually I forgot to put on my side, but it's important to mention, is the pesticide resistance, because the overuse of pesticide can lead to the development of pesticide-resistant pests, making it difficult to control them. Next slide, please. To tackle these risks, in the region and globally, the FAO has the framework of the life cycle management of the pesticides and supports the reduction of pesticide use and its related risk by through various steps, like supporting governments in regulating pesticides, provide recommendations and legal support, supporting national authorities to strengthen their inspection and control system, as well as regulatory frameworks to assess, ban, or discourage the use of the most toxic pesticides that came up in the previous presentation by Alejandra. And moreover, we also supporting building farmers' capacities with various trainings, and the FAO approach, the farmer field school approach, and train them on integrated pest and pesticide management, and also improving their food security and livelihoods and raising awareness about risk of chemical pesticides, as well as the effective and low risk alternatives. Next slide, please. Overall, the use of pesticides carries a risk to human health, environment, and economy. There is an important to be cautious when we use pesticide and make sure that we are able to adopt the alternative plant protection technologies and approaches like integrated pest management, and help the farmers in our region and throughout this project to select and promote the use of non-chemical pest control methods and effectively respond to the challenges which the pests creating throughout the production, and make evidence-based decisions related to pesticide applications. Therefore, in the framework of this project, among other approaches, we selected the integrated pest management as our main approach to be promoted to farmers. But why we selected IPM, and what is the IPM itself? As you can see on my screen, I created this small infographic. All of us know very well that we are now more than 8 billion of us on this planet. And based on the estimations, this number just will grow until 2050. Therefore, we have to identify ways how we can increase food production and have more yields, while we are protecting the biodiversity and the ecosystem that we are using to produce these crops. Therefore, it's really important to move toward a more sustainable agri-food system, which not impacting negatively our biodiversity and environment. The integrated pest management is a holistic approach that uses multiple protection tools to increase the to decrease the damages done by pests in agriculture and minimize the harm for nature, biodiversity, and useful organism and human health. The tools and strategies suggested by IPM for producers are aiming to maximize their production and minimize their losses by sustaining ecosystem functions and biodiversity. Next slide, please. But how we can promote this approach? As I mentioned, this is a dynamic process that makes farmers use an ecological system approach and encourages the producer to consider and use the full range of pest control options available given the economic, environmental, and social considerations. But for this, we have to reach them, and we have to provide them alternative options to learn more about these practices. So basically, we have 4 main tools in our hands that as FAO we are using under the during our work and also under this project. First of all, we working through capacity development actions. In a few presentations before, Tania Santivanez introduced you the sub-regional strategy that we have on IPM, which includes all of these elements. And some of the elements, or one of the elements, is our trainings that we are providing for farmers and extension service providers on IPM related to various crops. The main target crops was selected country by country based on their priorities. We're also doing promotion actions. Our work includes awareness raising campaigns on IPM. We are publishing booklets, info materials, and brochures for farmers on various topics. And also, we develop university curricula and organize webinars and workshops on IPM to make sure that we are reaching out as many stakeholders as possible and include as many people from the society to raise awareness on the importance to decrease the pesticide usage as possible. The third element of our work is evidence generation. We are implementing IPM trials in our beneficiary countries where we generate local data and evidence and how the IPM impacts the production and how we can, and with these results, we can help to spread the approach for broader audience. And the last but not the least important element is the policy support, because it's not enough to promote the approach from bottom up, but also we need to have a good policy framework and an enabling environment to establish the integrated pest management at national level. Therefore, we are providing policy support, review policies, and enhance them to ensure the integration of the approach to the national frameworks. Next slide, please. As I have just 15 minutes today, I decided to not go through all of the elements of our strategy and not going to the details of all of the trainings and various works that we are doing. But I wanted to bring to your attention our trials. And I brought one case study from Türkiye where we worked from 2020 on the promotion of integrated pest management practices in apple orchards. In Türkiye, already a lot of work is done related to IPM, the government supporting the farmers to implement this practice. However, the acceptance is still low. Therefore, we were decided to start the comparison trials in 2020 in apple orchards in Isparta region, which is one of the important apple producing regions in Türkiye. And this is economically the most important fruits for the country. And the majority of the farmers still follow conventional production practices related to apple production, which can mean 14 to 20 chemical application in one season. With the trial, we aimed to compare the conventional production practice, what the farmers in the moment using for apple production, and to compare this to the integrated pest management methodology we developed and the organic farming approaches. We selected a research partner, the Isparta Fruit Research Center, and the first year we established the trial. Based on the results, we were really let's say, motivated to continue the work because we selected one main pest against we are tested our ideas. That was the apple codling moth, the Cydia pomonella, where we focused all of our research. And based on what we found, the pesticide use with integrated pest management can be reduced up to 70%. That was the first year result, which showed us that if we apply alternatives, what in our case was pheromone traps and pheromone dispensers, we can exchange chemical applications to biological protection tools. From 2021, we decided to broaden up our trials and involved in total 46 producers from the same region who previously participated on our trainings and visited our trials. And they brought 90-hectare apple orchard under IPM production. With the support of our partners, we provided them advisory services and with the tools of, and also we trained 160 more farmers on IPM and marketability opportunities related to products and how they can find their target markets. And on all of these areas, we introduced the similar integrated pest management procedures that we did in the first year. All of the farmers was agreed to follow our methodology, which was basically relied on the forecasting, the advisory services that our partner provided them, and also the biological protection tools. Please go to the next slide. You can see the table with the results from 2022. As I mentioned, these farmers, before they joined to our trials, they used 12-13 application of chemicals against the apple codling moth in their practices. With the trials results and the advisory services, we provided them suggestions to make decisions related to various plant protection methodologies. One of them was the availability of pheromone traps to forecast the apple codling moth and the pheromone dispenser application for their orchards to avoid the pesticide application. With this approach, some of the farmers, we were able to reduce the pesticide application up to 3 times per year against apple codling moth, but the majority of them used 4 or 5 times pesticide applications. It still can be seen that it's one thing that we reduce the pesticide application, but also we have to provide reasons farmers beside the environmental cautiousness to follow our practices. Therefore, we also made economical analysis how the various application methodologies and different protection tools can impact on the income of the farmers and can also income of the total expenses. So you can see in this table that comparing to the conventional production, which is in the last column, if they don't apply pesticides, they have some profit loss. But if they, if we're not applying pesticides at all against apple codling moth, we had the loss. But if we reduce the pesticide applications to 4 or 5 times a year, the net profit of the farmers can stay the same or even better than it was before. So the integrated pest management approach basically reached its goal and kept the main pests under the economical threshold. So the farmers, with the decreased application of the pesticides, they also saved up some money in the sense that they didn't have to buy the same amount of pesticide they did before, or they would do when they would do the classical approaches. And they can, this is a good selling point to promote the integrated pest management beside the obvious health and environmental benefits of this approach. I think what is also important to mention as like the closing sentence of my presentation, that we also learned a good lesson, because we wanted to make the trial as punctual as possible. Therefore, we selected this main pest, the apple codling moth, that we worked with. But after 2 years, the results also showed us that the reduced pesticide application and that we didn't take care about, throughout the trials, we didn't put enough attention to other pests which possible to present in the apple orchards, that these pests, the population are increased. And now the farmers, this year, we are changed our methodologies, and in 2023, we will have a more holistic approach related to pest management in these orchards to step forward from the research approach and be a more practical. And also help them to tackle the raising pests with alternative methodologies. And for this year, we will test various mites in the apple orchards. This is what I wanted to share with you related to our Turkish case study. I will be here after the presentation. If you have any further questions, I'm happy to answer. And on the next slide, there is my contact details if you would like to contact me separately. Thank you very much.
Thank you very much, Zsuzsa. And I like, obviously, the picture on the right of your last slide. That's also an information product we developed under the project specifically for small children. One of our mothers in the project developed that, probably always having her child in mind, but also all the other children. With this last presentation, it's now there's an opportunity to ask various questions, I think.
Okay, Alexandra, do you have any idea about the cost of the, for example, per ton for the recycling of the plastic containers? What you have experienced?
Okay, it's yeah. Okay, thank you. This question is quite good. So usually you don't have the exact estimations on the cost of the collection and disposal of the containers, because, as I said, each country is unique, and therefore you need to take into the consideration a lot of the obstacles. However, when we're talking about, let's say, Western Europe, for example, the cost of the collection scheme of the container management system is about 70 to 80 euro cents per kilo. That's how it works in Europe. What will be the cost of the collection? Collection and recycling, all in all.
Okay. Okay. Yeah. Thank you. And question for Zsuzsanna. On the last slide you show us, maybe we can go to the previous slide, Stefan. Yes. So the calculations that you made about no pesticides applied, and for example 3 pesticides application, or even the 13 one, it's kind of less than 10%, let's say, the difference in the price. Did you calculate only the cost of the pesticides, or also you calculated the cost of the labor work and water and all kind of things, or it's only pesticides?
No, it's the full cost of the management of the orchard.
Okay, thank you.
Sasha, maybe what was not clear is they save on the pesticides, but they have obviously to buy pheromone traps. The pheromone traps are substituting the lesser use of pesticides. This is all taken into calculation, and the bottom line is usually with the pheromone traps you hang them up at the beginning of the season, and then instead of having to go 15 or 20 times to the field and spray, you go just at the beginning of the season, you spray 2-3 times, and the rest of the season, the pheromone traps do the rest.
That was my question, the time saving. So it's not the same when you go once or when you go 15 times on the same field.
Yes, I mean, you get about the same profit, but with less work. And I mean, assumedly, because it has seen less pesticides, probably the product is also of better quality. But as Zsuzsa has also told in the end, it's very important. We reduce use of pesticide, but then we see the introduction of other pests now coming. So we suddenly have mite, which was not existing before. So now, as Zsuzsa said, this year we will look on where is the good balance to keep all the different pests in check with as little use of pesticides and as much use of alternatives to chemicals.
Yes, and if I may add to this, that this is one of the biggest advantage, but in the same time, the disadvantage of the biological protection tools, that they are extremely targeted. And now we targeted one pest. It means that the pesticide we didn't use in the apple orchard that was more general impacts on all of the insects. But our alternative option covered just the apple codling moth. So this is a good point, or I felt it's important to raise that this is not a mistake, or that the integrated pest management always should be applied in a holistic manner. So we should make sure that when we are taking out one element from the formula, we are covering everything that was covered by this element.
Thank you, Zsuzsa. I think that's a very important point you raised. And it also goes in line with what Mark said earlier, that with chemicals, we have been oversimplifying systems to the verge of death, and now we have to reintroduce the complexity of good agriculture. Then I would like to inform you before we wrap up the session of one initiative we are currently preparing in FAO. I assume you have also as a takeaway of today's session that in Central Asia we had a very massive use of pesticides for a long period due to the cotton production, but also the managed economy of the Soviet Union. But we don't have really any obsolete pesticides left today, like something in a bag with a label on it in a store with a normal roof. Our big problem today is everything is mixed. We don't know what it is, and over time it has got into the ground, or it was buried in a managed landfill, or as Umed told us, in Tajikistan there are a lot of wild landfills. So the main problem which we face is essentially contaminated soil and contaminated materials. In my assessment, I would say maybe 15% of the volumes we have are obsolete pesticides in terms they are so concentrated that you can incinerate them. But the other 80 to 85%, we have to find other solutions, because incinerating soil is simply not economic at a certain moment, or how you want. So we have to find, we have to develop in the coming years sort of a toolbox with various instruments on how we manage that. And in my vision, sort for the mid-concentrated wastes, where we have in the percent levels pesticides in soil, probably that would have to go to managed landfills, with obviously everything which comes above on it. But the largest part of the volumes obviously would be soil with several hundred of ppm, and which would obviously then go probably into direction what Tinatin and Assil have presented. Would bioremediation and phytoremediation be an economic approach to clean up these soils, and over the years even return them again to some productive use, whatever then the use is? I also remember a lot of the farmers we met in November during these awareness raising seminars which Umed presented. They were all concerned about that their soil might be or is contaminated from former DDT use. So it's not a theoretic problem. Farmers have really an issue with that. And we are considering establishing a Central Asia working group on contaminated soil. The reason for this is this project will end in 2 years, and we want to avoid that everyone drops the ball and nothing happens on this very serious topic, but that we have in the next 2 years, we build up a vessel where interested experts, government representatives, NGOs, industry party representatives would agree to meet, maybe having a meeting every 2-3 months in a virtual manner to exchange on what are the problems we have. It's a miss of a vision of a strategy, or we have a highly contaminated site, we don't know what to do, or we have developed, we have some trials, we have interesting results, but we are not clear about the next steps, so that we would have a vessel which would bring together all the different stakeholders and push forward the topic of contaminated soil beyond this project or any other project which will come. It's still a lot of thinking, what would be the best way? In my understanding, we have obviously some academic potential in the region, but for example, we miss the scaling up from something which is 10 by 10 meters to something which is several football fields in size. Also, as Tinatin said, we know that her bacteria very well decompose our POPs, but we are not clear yet. They decompose them into what? Maybe also something which is not very nice. And also our problem is mainly composition of POPs plus heavy metals. So how do we deal with this very complex challenge? Governments in principle start to have an understanding of, yes, contaminated soil is an issue and we need it for agriculture, but also for the general public health. But what we need to do, so obviously there's also such a working group would be a good learning opportunity for government to better understand what is the challenge, but also we as a government have to do to promote this process in terms of a strategy, in terms of annual budgets, in terms of targeted support, in terms of specific cleanup projects. So this is a bit the idea of this upcoming working group. If somebody would be interested to participate there in a pro bono manner, I mean, maybe that might generate in the future then some projects, because obviously at the end of the day, money is always needed. But if in a first step you would be interested to participate in these discussions in a pro bono manner, I would be very grateful if you could contact me, and I will then over the next months then probably have a first initial meeting with all the different stakeholders. And obviously it would be important that we all can communicate either in English or in Russian. So that would be sort of the two languages we probably will have for practical reasons. Are there any immediate comments, or as I said, if you're interested, please contact me after the meeting.
Stefan, can I?
Yes, please, Tania.
Yes, I think that as you mentioned, this is the one of the idea that we have in order to strengthen the national capacities in the region. And it would be good to hear, to listen from the countries now. Since you have people from the representative for different countries, it will be good to hear from them what they are thinking about this proposal. So it will be good to hear from Azerbaijan colleagues, from Kyrgyzstan, from Tajikistan, from Kazakhstan. So this could be very interesting for us to know what they think about this proposal.
Okay, I think then we will, Javidan has already the microphone in the hand, is ready to start.
Thank you again. I think firstly we should revise our legislation to provide all doing process, and after that we can do we can get result over the process. And in my opinion, firstly we should prefer to remediation of soils, not chemicals or other mechanical ways. I think we should prefer to biological, microbiological ways. For example, our valuable experts presented the presentation. I'm not sure for today in Azerbaijan how is the situation about that, but I think that we can cooperation with other regions about it, and we can make the same system in Azerbaijan, for example, Tajikistan or Kazakhstan practice.
Thank you. Umed, could I give you, as the next person, the microphone?
Sure. We have discussed with you, Stefan, this idea, and I found it very, very well, because the initiative, the lack of initiative in our countries, Central Asian countries, the main problem why we are starting to solve this problem now. We had information about the contamination of soil and mini burials in our country many years ago. But unfortunately, we couldn't deal with the management and process of attracting donors to this problem. And only now we are trying to solve these problems, when a lot of mini burials already stolen. I mean, the people got these pesticides for their purposes, but still it's not late to start. And your idea to create like a network between our countries, I found very good. And from our side, as NGO, we are ready to join to this initiative. Besides, I suppose that it will be the best solution to attract also farmers whose opinion will be very valuable for this network and for decision making. Thanks.
Thank you very much, Umedjon, for your good comments. I think next would be Tinatin.
We have today a lot of presentation about situation, how manage pesticides in countries, in Central Asia countries. We have common problems, common situation. I think we have to develop some joint projects for Central Asia countries, using academic potential, using progressive ideas, using technologies. Maybe not only biotechnologies, only with some robot technologies to improve our approach, to improve the removing the residues contamination in soils in Central Asia countries. On my project, I can be extend my project outputs, extend my project idea and the technologies in other neighbor countries, using our selected active degrading bacteria, because for selecting such bacteria, we have spent a lot of time, because in lab scale, we have a lot of screening. Then we had trials in field conditions. We approve these microorganisms can work in field conditions, in very different conditions. I think by supporting FAO, by supporting another international organization, all together we have to improvement in removing the pesticides, maybe in some short period, maybe in some 10 years, but 10 years this short period, because we have to use ecologically friendly approaches to removing, because in our country no chemical technologies to shipping to other countries, to using some physical chemical technologies to remove. I think we have to choose the more ecologically friendly methods to removing, the pesticides in soils, in water places. I think we have to develop joint projects to make some good strategies, to make tools, scientific tools, practical tools to remove the pesticides. Thank you.
Would that sort of more less answer your suggestion?
Yes, just yes, it is good to hear the countries in order to know if this is a good idea. In 2019, just for the information, we established also a regional network on pesticide management. So maybe we can linkage this to this network, and this could be like a subgroup of this regional network on pesticide management for Central Asia and Europe. So also I wanted to highlight that the idea to have this working group is also to include private sector, NGOs already, government, as well as academia. So this is important that all the actors to be together in this working group. As mentioned by Tinatin, one of the idea to have this working group also is to exchange information, to exchange experience, and to have common projects in order to solve this problem in Central Asia. And also I think that not just in Central Asia, it's necessary to think about also Moldova, about also Turkey, and several countries that in our region. So, but we can start with Central Asia countries. Over to you, Stefan.
Thank you very much for these good suggestions, which I noted down already.
I've been sort of making notes and listening to the presentations as we've gone along. I've been taking note as well of some of the discussions that developed yesterday. And I think that there is no question about the fact that certainly in the Central Asian countries, and this may be common to other regions that we haven't heard from today, the problem of obsolete pesticides and the legacy of soil contamination, poor storage sites, burial sites, and so forth continues. So there's no question about the fact that there is a need to continue to pay attention to this, as we've just discussed. There needs to be a continuity in the countries beyond the projects that FAO is bringing or that other agencies are bringing. The countries themselves need to take ownership and put in place mechanisms that allow solutions to be developed and implemented on a long-term basis. These are problems that will need long-term attention. It's not going to be solved today, tomorrow, or next year. So the stockpiles themselves need attention. And as was said in one of the discussions yesterday, this needs to be part of an integrated approach to hazardous waste management in each country. The stockpiles are a one-time, a spotlight on a problem that happened in the past, can be dealt with, and will hopefully disappear forever. But that on its own does not justify the creation of a hazardous waste destruction facility. What the country needs is an infrastructure that deals with hazardous waste from all the streams in which those types of waste are being generated, and into which the legacy stockpiles can also be fed until they are removed and destroyed. But the infrastructure for dealing with hazardous waste needs to continue to operate, dealing with whatever other wastes are being generated. You must remember that when you build something like an incinerator or any other kind of technology that deals with waste, it is a big investment which needs to be fed in order to justify that investment. So you have to make sure that there is a continuity of supply to justify the investment in that technology. And we've heard today that some of the countries are looking at developing those kind of solutions. When we get rid of the chemicals, we still have the problem of contaminated soil, contaminated sites, maybe burial sites, and we need to continue the efforts to identify them, isolate them, make sure that they're not being used for habitation, for cultivation, for grazing, and find ways of dealing with them, which may include long-term but viable, locally applicable solutions like phytoremediation, bioremediation, and so forth. So these things need further research, they need more implementation, they need scientific publications that others can look at and learn from and follow. I was going to ask actually, is your research published? It is? Yeah. It will be.
Tinatin just said that her results are in the review process for some scientific publication.
And that's excellent. That means it's accessible to others. And the phytoremediation work also is published or will be published? Yes. Great. Okay. This is important to get this information published and accessible to all so that they can learn from it and apply it to their situations. So in addition to these solutions, we have also heard that the pesticides themselves, they continue to be used, they need better management. So every country needs to look and put in place the resources to strengthen and effectively implement and enforce their regulations and life cycle management of pesticides in accordance with code of conduct and the conventions and so forth. We've heard about container management today and the complexity of establishing these kind of systems, but the importance of pursuing them, setting up sustainable systems, self-sustaining systems that include all the relevant stakeholders and that engage in collecting and removing these containers from use and dealing with the waste, along with possibly other types of waste that might be generated, such as agricultural plastics. And finally, I mean, both at the beginning of the session and at the end of the session, we heard that actually we can do without a lot of the pesticides that are still being used. We can significantly reduce and possibly eliminate the use of pesticides in many situations, looking at other solutions that are available and that will ensure longer-term sustainability of agricultural production. And that includes looking at ecosystem services, mechanical controls, biological controls, and low-risk strategies, including new technologies such as digital technologies, robotics, and so forth, that can provide a lot of the solutions for the future. So there is a future. We can be optimistic. We don't need to dwell on the past and be unhappy and depressed about the legacy that's been left. We have solutions. We need to work together to make sure that they're effectively implemented into the future. Thank you.
So thank you very much, Mark, for these closing and upbeat observations. And so off to work. There's a lot to be done over the coming years. But first, let's have lunch. I want to say thank you very much to all the people and speakers who joined online. A very big thank you to the interpreters. I really appreciate very much your work, your stamina, and your quality of translation. And to all the audience, a lot of learning here, a lot of new ideas on how we can solve all these problems and how we can do things better in future. All the best to all.